हेलो हेलो।
इसको रोल कर दीजिए। Hello, hello, mic check. Hello, hello. Hello, hello.
ubiquitous in both its presence and its applications. Light makes life possible on Earth and also allows us to delve into the depths of universe to unravel its myriad mysteries. Raja Ramanna Center for Advanced Technology, Indore, an R&D unit of the Department of Atomic Energy, Government of India, is dedicated to advancing the science and technology of light. RRCAT is home to two major sources of light, namely lasers and synchrotrons, and the Light Exploratorium is dedicated to generate curiosity and increase awareness in this vibrant field of science. Under Azadi Ka Amrit Mahotsav, Light Exploratorium was inaugurated on 8th July 2022 by Padma Vibhushan Dr. Anil Kakodkar, Chancellor HBNI, former Chairman AEC and Secretary Department of Atomic Energy, Government of India. The Light Exploratorium is housed in the erstwhile Sukhnivas Palace, which was a summer recreational point developed by the Holkar dynasty of Indore in the year 1903. The palace is situated on the banks of Bhamori Lake and is surrounded with natural beauty and rare species of flora and fauna. The Light Exploratorium at RRCAT, spread over an area of about 630 square meters, is a unique and one of its kind museum in the country that showcases light in its various manifestations and their applications. The Light Exploratorium houses about 25 exhibits spread over two floors in the Sukhnivas Palace. The exhibits are hands-on models that students can experiment with to understand the various properties of light and their uses. The Exploratorium hopes to act as a bridge between textbooks and formal laboratory activity in understanding light and serve as a teaching aid for science teachers in explaining about light and its properties. The exhibit layout starts in a central hall which houses a banner with a timeline of important events associated with light in the history of mankind. The bottom half of this banner displays the electromagnetic spectrum in all its glory, starting from very low frequency and all the way up to gamma rays. Subsequently, one walks through various exhibit rooms in sequential fashion, exploring the wave nature of light, the particle nature of light, geometrical optics, the finite speed of light, biological effects of light, physiology of vision, etc. An exhibit on the Raman effect is set up in the room dedicated to Sir C.V. Raman. The basement floor houses exhibits on discovery of lasers, modern light sources, applications of light in industry and biology, etc. There is an exhibit dedicated to our star, the Sun, in the Sun Room, followed by an exhibit on light and gravity demonstrating the use of laser interferometer for detection of gravitational waves. The Light Exploratorium endeavors to make learning about light both interesting and fun. The exhibits in the Light Exploratorium will be constantly upgraded and modified so that people visiting it after a while would have something new to learn about light. Light is ubiquitous in both its presence and its applications. Light makes life possible on Earth and also allows us to delve into the depths of universe to unravel its myriad mysteries. Raja Ramanna Center for Advanced Technology, Indore, an R&D unit of the Department of Atomic Energy, Government of India, is dedicated to advancing the science and technology of light. RRCAT is home to two major sources of light, namely lasers and synchrotrons, and the Light Exploratorium is dedicated to generate curiosity and increase awareness in this vibrant field of science. Under Azadi Ka Amrit Mahotsav, Light Exploratorium was inaugurated on 8th July 2022 by Padma Vibhushan Dr. Anil Kakodkar, Chancellor HBNI, former Chairman AEC and Secretary Department of Atomic Energy, Government of India. The Light Exploratorium is housed in the erstwhile Sukhnivas Palace, which was a summer recreational point developed by the Holkar dynasty of Indore in the year 1903. The palace is situated on the banks of Bhamori Lake and is surrounded with natural beauty and rare species of flora and fauna. The Light Exploratorium at RRCAT, spread over an area of about 630 square meters, is a unique and one of its kind museum in the country that showcases light in its various manifestations and their applications. The Light Exploratorium houses about 25 exhibits spread over 2 floors in the Sukniwas Palace. The exhibits are hands-on models that students can experiment with to understand the various properties of light and their uses. The Exploratorium hopes to act as a bridge between textbooks and formal laboratory activity in understanding light and serve as a teaching aid for science teachers in explaining about light and its properties. The exhibit layout starts in a central hall which houses a banner with a timeline of important events associated with light in the history of mankind. The bottom half of this banner displays the electromagnetic spectrum in all its glory, starting from very low frequency and all the way up to gamma rays. Subsequently, one walks through various exhibit rooms in sequential fashion, exploring the wave nature of light, the particle nature of light, geometrical optics, the finite speed of light, biological effects of light, physiology of vision, etc. An exhibit on the Raman effect is set up in the room dedicated to Sir C.V. Raman. The basement floor houses exhibits on discovery of lasers, modern light sources, applications of light in industry and biology, etc. There is an exhibit dedicated to our star, the Sun, in the Sun Room, followed by an exhibit on light and gravity demonstrating the use of laser interferometer for detection of gravitational waves. The Light Exploratorium endeavors to make learning about light both interesting and fun. The exhibits in the Light Exploratorium will be constantly upgraded and modified so that people visiting it after a while would have something new to learn about light. Light is ubiquitous in both its presence and its applications. Light makes life possible on Earth and also allows us to delve into the depths of universe to unravel its myriad mysteries. Raja Ramanna Center for Advanced Technology, Indore, an R&D unit of the Department of Atomic Energy, Government of India, is dedicated to advancing the science and technology of light. RRCAT is home to two major sources of light, namely lasers and synchrotrons, and the Light Exploratorium is dedicated to generate curiosity and increase awareness in this vibrant field of science. Under Azadi Ka Amrit Mahotsav, Light Exploratorium was inaugurated on 8th July 2022 by Padma Vibhushan Dr. Anil Kakodkar, Chancellor HBNI, former Chairman AEC and Secretary Department of Atomic Energy, Government of India. The Light Exploratorium is housed in the erstwhile Sukniwas Palace, which was a summer recreational point developed by the Holkar dynasty of Indore in the year 1903. The palace is situated on the banks of Bhamori Lake and is surrounded with natural beauty and rare species of flora and fauna. The Light Exploratorium at RRCAT, spread over an area of about 630 square meters, is a unique and one of its kind museum in the country that showcases light in its various manifestations and their applications. The Light Exploratorium houses about 25 exhibits spread over 2 floors in the Sukniwas Palace. The exhibits are hands-on models that students can experiment with to understand the various properties of light and their uses. The Exploratorium hopes to act as a bridge between textbooks and formal laboratory activity in understanding light and serve as a teaching aid for science teachers in explaining about light and its properties. The exhibit layout starts in a central hall which houses a banner with a timeline of important events associated with light in the history of mankind. The bottom half of this banner displays the electromagnetic spectrum in all its glory, starting from very low frequency and all the way up to gamma rays. Subsequently, one walks through various exhibit rooms in sequential fashion, exploring the wave nature of light, the particle nature of light, geometrical optics, the finite speed of light, biological effects of light, physiology of vision, etc. An exhibit on the Raman effect is set up in the room dedicated to Sir C.V. Raman. The basement floor houses exhibits on discovery of lasers, modern light sources, applications of light in industry and biology, etc. There is an exhibit dedicated to our star, the sun, in the sun room, followed by an exhibit on light and gravity demonstrating the use of laser interferometer for detection of gravitational waves. The Light Exploratorium endeavors to make learning about light both interesting and fun. The exhibits in the Light Exploratorium will be constantly upgraded and modified so that people visiting it after a while would have something new to learn about light. Light is ubiquitous in both its presence and its applications. Light makes life possible on Earth and also allows us to delve into the depths of universe to unravel its myriad mysteries. Raja Ramanna Center for Advanced Technology, Indore, an R&D unit of the Department of Atomic Energy, Government of India, is dedicated to advancing the science and technology of light. RRCAT is home to two major sources of light, namely laser sensing synchrotron, and the Light Exploratorium is dedicated to generate curiosity and increase awareness in this vibrant field of science. Under Azadi Ka Amrit Mahotsav, Light Exploratorium was inaugurated on 8th July 2022 by Padma Vibhushan Dr. Anil Kakodkar, Chancellor HBNI, former Chairman AEC and Secretary Department of Atomic Energy, Government of India. The Light Exploratorium is housed in the erstwhile Sukhnivas Palace, which was a summer recreational point developed by the Holkar dynasty of Indore in the year 1903. The palace is situated on the banks of Bhamori Lake and is surrounded with natural beauty and rare species of flora and fauna. The Light Exploratorium at RRCAT, spread over an area of about 630 square meters, is a unique and one of its kind museum in the country that showcases light in its various manifestations and their applications. The Light Exploratorium houses about 25 exhibits spread over two floors in the Sukhnivas Palace. The exhibits are hands-on models that students can experiment with to understand the various properties of light and their uses. The Exploratorium hopes to act as a bridge between textbooks and formal laboratory activity in understanding light and serve as a teaching aid for science teachers in explaining about light and its properties. The exhibit layout starts in a central hall which houses a banner with a timeline of important events associated with light in the history of mankind. The bottom half of this banner displays the electromagnetic spectrum in all its glory, starting from very low frequency and all the way up to gamma rays. Subsequently, one walks through various exhibit rooms in sequential fashion, exploring the wave nature of light, the particle nature of light, geometrical optics, the finite speed of light, biological effects of light, physiology of vision, etc. An exhibit on the Raman effect is set up in the room dedicated to Sir C.V. Raman. The basement floor houses exhibits on discovery of lasers, modern light sources, applications of light in industry and biology, etc. There is an exhibit dedicated to our star, the sun, in the sun room, followed by an exhibit on light and gravity demonstrating the use of laser interferometer for detection of gravitational waves. The Light Exploratorium endeavors to make learning about light both interesting and fun. The exhibits in the Light Exploratorium will be constantly upgraded and modified so that people visiting it after a while would have something new to learn about light.
Honorable dignitaries, learned faculties, seniors, and my dear fellow mates, a very good morning to one and all. As you all know that HBNI is organizing the theme meeting on life sciences for the first time, and we are honored to host it here at Raja Ramanna Center for Advanced Technology, Indore. I, Mahima Rastogi, Junior Research Fellow of HBNI at RRCAT, feel extremely privileged to extend a very warm welcome to all of you to this inaugural ceremony of theme meeting. So, to begin with this ceremony, I would like to request the chief guest of today's function, Professor Amlan J. Pal, Director, UGC DAE Consortium for Scientific Research, Indore, to please come onto the dais. I request our Honorable Director, Dr. Shankar V. Nakhe, to please escort him onto the dais. I further request Dr. P.D. Nayak, Dean HBNI, Dr. Sunil Ghosh, Associate Dean, Life Sciences HBNI, and Dr. Satyaram Mishra, Dean Academics HBNI at RRCAT, to please come onto the dais. I request Dr. S.K. Majumdar to please accompany them onto the dais. Thank you, sirs. Now, I request Honorable Director, Dr. Nakhe sir, to please welcome Professor Amlan J. Pal with a bouquet. Thank you, sir. Now, I request Dr. S.R. Mishra to please welcome Dr. P.D. Naik, sir, with a flower bouquet. Thank you, sir. Now, I request Dr. Shovan Majumdar, sir, to please welcome Dr. Sunil Ghosh with a flower bouquet. Thank you, sir. So it is considered auspicious to begin a ceremony with a lighting of a lamp. I request the dignitaries on the dais to kindly light the lamp. Thank you, sir. Now, I would like to request Dr. Shovan Majumdar, sir, convener of the HBNI theme meeting on life sciences, to give his introductory remarks. Sir, please.
Good morning, everybody. Honorable Chief Guest of today's function, Professor Ramnan Jepal, Director, UGC Consortium for Research, Scientific Research. Dr. P.D. Naik, Dean HBNI Mumbai. Dr. Sunil Ghosh, Associate Dean Life Sciences HBNI Mumbai. Dr. S.R. Mishra, Dean Academic HBNI RRCAT. Professor Annie Hassan, today's keynote speaker, who has come all the way from Kamineni Hospitals, Hyderabad. Professor M.B. Bera, today's evening lecturer. Professor Prasanna from ACTRAC, Deputy Director of ACTRAC. Professor Hema Rajaram, Dean Life Sciences, BRC. Professor Pal, Associate Dean of HBNI. All distinguished faculties and deans of different constituent units of DAE. My senior colleagues, friends, students of HBNI who have come from different constituent units, also from RRCAT. So I welcome you all to the first theme meeting on life sciences, which is being organized at RRCAT. As you know that this theme meeting is no less than a conference. But the only difference is, why theme meeting? This theme meeting is the brainchild of HBNI think tank there at Mumbai, including our Honorable Vice Chancellor, Professor P.R. Vasudev Rao, Dean HBNI, Professor P.D. Naik, and many others associated with HBNI. The theme meeting is to interact among, this objective is to basically lay a platform where the faculties and students from different constituent units of HBNI can interact with each other. So this is common always for any conference. This is the objective of any conference. But here the difference is that many a time what happens that in our different DOE units, particularly, they do not know each other, what are the facilities existing in a particular field of research. And the students, they also are not aware of any such facilities or what are the facilities available at different constituent institutes of HBNI. So this objective of this particular theme meeting is to address this particular issue. And I'm sure that all the students and faculties who have come here will have a very fruitful 3 days interaction through scientific sessions here. And as you have seen that this RRCAT is a very picturesque, particularly at this point of this year or time, it is lush green just after rainy season, or rainy season is continuing. This theme meeting will comprise invited talks from nominated faculties or from different constituent institutes, and poster presentations by the PhD students of different constituent institutes. And there will be 2-day poster sessions, today and tomorrow. And third day, there will be only scientific sessions followed by valedictory ceremony. And there will be special attraction is that there will be evening lectures by experts in respective fields, and that will give you a glimpse of what is happening in the area of life sciences, but little bit different than what we perceive. So with this introduction, I welcome you again to this inaugural function and to the HBNI theme meeting on life sciences. I'm sure that you will enjoy your stay and obviously your knowledge base and will get enhanced during these 4 days. Thank you very much.
Thank you, sir. Now, I would like to request our Honorable Director, Dr. Naki sir, to please deliver his opening remarks.
Today, Chief Guest, Professor Amlanji Paul, Professor P.D. Naik, Professor S.K. Ghosh, Dr. Satyaram Mishra, and Dr. Majumdar, today's keynote speaker, Professor Ani Hassan, and many other dignitaries. I welcome you all to this first HBNI theme meeting on life sciences. At the outset, I would like to thank HBNI for granting this meeting to our institute. Otherwise, RRCAT is well known for its contributions in the area of lasers and accelerators, and definitely their applications in diverse fields. But the applications in life sciences are not so much talked about, and we thought it is a right opportunity to have our exposure to the world. It is at least to the HBNI in this particular area, and we'll have interactions because as we know, these lasers and accelerators are having extending applications in the area of life sciences. So we'd like to have more of a collaborative activities in future, and this meeting is the right platform for this. So I thank HBNI authorities for granting this meeting to RRCAT. Our team, led by Dr. Majumdar, has taken a lot of efforts, and we had a good collection of speakers, and not only the HBNI exposure, but there are two very good evening lectures and keynote speaker today will take to the totally new world and new applications where all the participants will be exposed. I had a small appeal here at this opening remark for the participants particularly. You explore the facilities that are available here, explore the personalities that are existing here, that is in terms of their areas of expertise and where they can contribute, or your peer student members, and explore the possibilities what we can do with the collaborative activities in future, because synergy is the keyword now. Unless we have synergetic efforts, will not be able to move fast. And as our Prime Minister has said, this is our century now, and coming 25 years, particularly, we are quite hopeful from our young students that they will take the sciences and technology to the new heights. And for this purpose, this type of synergetic efforts are very much required. So I once again thank you all for coming to this session, and particularly the external participants and faculty members, and I wish them a very fruitful stay here and a very enjoyable stay. Thank you.
Thank you, sir. Now, I request Dean HBNI, Dr. P.D. Naik sir, to please say a few words.
Good morning to all, and welcome to this first HBNI theme meeting on life sciences. Professor Amlan Pal, Director, VGCDE Consortium for Scientific Research, Indore. Dr. S.P. Naki, Director, RRCAT. Professor S.K. Ghosh, Rajaramana Fellow and Associate Dean Life Science, HBNI. Professor S.R. Mishra, Dean Academic at RRCAT. Professor S.K. Majumdar, Head Laser Biomedical Application Division, RRCAT. On the dais. Of the dais, we have many personalities. Most notable among them are Professor Dr. Annie Asan, going to give the keynote address today. Professor Prasanna Venkataman, Deputy Director, RRCAT, and Convener, Life Science at HBNI. Professor Ved, Professor Pal. I can see CP Paul, one of the active faculty of HBNI and Dean Student Affairs at RRCAT. And there are many other dignitaries, some of them are maybe not naming now, maybe Professor D.K. Maiti, he was involved in many of the HBNI activities, and he's one of the persons at HBNI, know everything about HBNI because he is working for HBNI more than any of us from 2013 onwards. And his constant guidance has also helped HBNI to arrange many meetings. Especially among them is the first meeting in this series. This series started, I'll just now explain about the genesis of this. It started with the discussion meeting on basic sciences at HBNI, which was been convener of that meeting was Professor D.K. Maiti, and with this all this idea that we should have a separate discipline-specific meeting should be there, it evolved. In fact, as I told you that I'm going to give you in brief the genesis behind today's team meeting. As you know, many of faculty from HBNI and some of the students also may be knowing that DE, right from its inception, placed high emphasis on sustained development in human resources for carrying out in the many activities, especially in nuclear science and engineering. With this in goal, as you know, we have set up many training schools to train young postgraduates in sciences and engineering graduates, popularly known as BRC Training School, which was previously at BRC and then it started at many other centers, including RRCAT, IGCA, EMD, NFC, IPR. In fact, this has generated the manpower requirement for the DE for research as well as its mission programs. But apart from these R&D centers of DE, there are many other aided institutes where there. They are also running the academic programs of their own, attached with different university nearby. Like SINP was running the academic programs with the Jadavpur University. So it has felt that it is better that to make uniformity, which many others are also thinking. In fact, Amlan Par just now also mentioned me, to bring everything together so that synergy, which Director RRCAT, Dr. Naki also thought about, it is important. Because individually we may be good, but to become excellent, we need a synergy among various units or various papers. In fact, nowadays, if you are working alone, you may able to publish some papers, but if you want something which is of very high value and which can have beneficial to the society in the immediate future, I think collaborative research only is the way out. And which is again the synergy which Director RRCAT talked about. With this in mind, Homi Bhabha National Institute was set up to bring all these 4 R&D units, BRC, IGCAR, RRCAT, VCC, these are 4 R&D units centers of which they are running the academic programs, and also aided institutes like HRI, SINP, IMSC, IPR, and many others. Total, we have 7 aided institutes together under a single umbrella, that is HBNI. And later on, NICER also was added. And this is just to have a synergic effect as well as the uniformity in the academic programs. And this has helped in last, HBNI was recognized as a deemed to be university in 2005, June 3rd, 2005. And with this, because of synergy among the R&D centers, along with aided institutes, has helped DE in many of its technology programs, and also help to develop many technology for the societal applications. And this was possible through the various academic programs, like integrated master degree, which is running at NICER, master degrees, which is now HRI started in 2017, and the search area of HBNI, because HBNI is basically a research university. The PhD programs, which are running under 2 names, integrated PhD, where we take the graduate students, and the PhD normal, where postgraduate in science and engineering are taken. Additionally, apart from chemical sciences, life sciences, physical sciences, engineering sciences, mathematical sciences, medical and health sciences, we are also encouraging many interdisciplinary programs. In fact, some of the programs we have the guide and co-guide are from the different discipline, so that student can do interdisciplinary research. Also, we have some of the programs which are guide is from the basic sciences, and other guide is from the technology side, so that basic sciences, the research done at basic sciences can be converted into the technology. So just this type of program also are running at various centers. Also, we have again one more program is the applied system analysis. Sorry. Here, because apart from this science discipline, engineering discipline, we also need manpower to address issues pertaining to nuclear law, the economics of the nuclear power, which is very important because finally economy dictates whether we can sustain with our nuclear power or not. So economics study also important. Then because of nuclear security, nuclear proliferations, intellectual property rights, humanities, social science, these are some of the domains also carried out under the applied system analysis. We have totally approved 48 programs, and 43 of them are running now. Apart from this, what I am explaining about the things, we have something like a unique programs. Like we have the master degree MSc in hospital radiopharmacy to make use of radioisotopes for medical applications. We also MSc in public health and epidemiology, which was becoming more important after the COVID-19. We have also MS in nuclear medicines and molecular image technology. Because image technologies are very important applications in medical field. And there we need a basic science person to understand the medical sciences a little bit, but also should be able to analyze the images. Image analysis became one of the important areas. In fact, many papers you can see MRI, high resolution MRI images. Many papers are coming. You see, there is hidden informations are available, and only experts with good analysis programs can really find out the details about the hidden things, which is not at Explore, and this is possible only we have the special bench or of studies, which they give more emphasis on image processing type of things. In fact, as you know, that HBNI provide the flexibility to the student in their learning processes. Our student can do part of their work in one of the CIs, other part in other CIs. It is possible. They can have a guide from one CI, co-guide from other CIs. They can take credit from any of our CIs to fulfill the credit requirement. Apart from that, they can also take credit from many institutes which with HBNI MOU, like IIT Bombay, IIT Madras, and many other institutes, well-known institutes. We have the MOU. They can take credit from there also. So we have giving the flexibility to the students. And we have seen that there is more interactions, synergy, but we want to enhance this synergy. And is it possible whenever they come together on the single platform, as Professor Mazumdar told, and interact? And you see, there is nothing like meeting online or nothing. When you physically comes together, discuss, a bonding is a different type of bonding is there. Online, you can see the face, you can discuss and other things, but that bonding, if you want to develop, physically you should meet, you have to discuss, and then that will be fruitful for both the institutes, or all the institutes, or India in general, to have the synergy type of research where contributions of various expertise, which Dr. Naki also explained, can be brought for the societal applications. And with this, as you know, that under the Professor Maiti organized a team meeting, which is known as discussion meeting on basic sciences during 6 to 8 April 2022. In this meeting was attended by all the director of our 11 CIS OCC. I'm thankful to all of them. Professor Naki also, Dr. Naki also attended that, and thanks sir for attending that meeting. And it is felt that it is good that this is the first meeting of that type, but it is necessary. A more focused theme type of meeting should be there, so that because what happens if we too big crowd, too many disciplines, the interactions for depth requirement for this subject, which is also required, it's difficult to bring about, because there are various audience. If there are physicists, chemistry, biology, engineering, and then you cannot go to the depth, because you have to be a superficial or which can understand by all the audiences, or at least some of them. So it is felt that a theme-based meeting should be conducted, and which was also been proposed by our chairman EEC, is also our chairman Council of Management HBNI, that it is better to have a theme-based meeting at various CIS OCC, so that there will be more interactions. And in this meeting also we can call about the other discipline person also who are interested to contribute in the area of team meeting. With this, first meeting was held at SINP on condensed matter physics on 22nd and 23rd June 2022. And it was beneficial to many of the participants attended that meeting, and we felt that this meeting should continue. Then we are discussing about the life sciences, chemical sciences, and other team meetings. I am glad that RRCAT, especially Dr. Nake, Dr. Misra, and Dr. Mazumdar taken the initiatives to conduct the team meeting at RRCAT on life sciences. Especially, I should thank Director RRCAT, Dr. Nake, for giving the full support in organizing of this meeting and taking part in the initial discussion how to organize other things in spite of his busy schedule. Thank you, sir. RRCAT team, as I mentioned, Ajit Upadhyay, Majumdar, Sharma ji, and many others. Especially, I should thank Professor C.P. Paul. He has given a lot of guidance in all the meetings. With the efforts of all the RRCAT team, Misra, Majumdar, Upadhyay, C.P. Paul, and many others, I may not able to name all of them. Today we are here to conduct this first team meeting on life sciences. I salute them all, RRCAT team, and also Professor Ghosh from HBNI for working day and night to organize this event. And I also should thank all of you for participating in this meeting physically, as well. There are many participants who are present online. I thank you all. I hope that you'll enjoy this meeting. Thank you all.
Thank you, sir. Now I request Dr. Sunil Ghosh, Associate Dean Life Sciences of HBNI, to please kindly come and say a few words.
Dignitaries on the dais, our chief guest, Professor Amlan J. Pal, Director, UGC BE Consortium for Scientific Research, Indore, Dr. Shankar B. Nake, Director, Rajaramanna Center for Advanced Technologies, Indore, Professor P.D. Nayak, Dean HBNI, Professor Satyaram Mishra, is Dean Academic at RRCAT, Professor Shobhan K. Majumdar, the convener of this today's meeting, dignitaries of the dais. I see many senior faculties. Professor Bera, who will be giving a evening lecture. Then our keynote speaker, Professor Annie Hassan, Kamini Hospital, Hyderabad. She has come here with a very short notice. Thank you, madam. All the faculties from all CI and OCC, students, ladies and gentlemen, and also there are many faculties and students who have joined online. So a very good morning to all of you, and I welcome you all to this today's team meeting.
which has been organized in the RRCAT Indore. Now, I'm very much thankful to Dr. Nakhe, Director RRCAT, for his willingness and wholehearted support for this program. Without his support, it could have not been possible to organize in such a short notice. This shows that he is a very high affection for the life sciences and also for life sciences fraternities. The team of faculties, which is led by Professor Shobhan K. Majumdar and Professor Mishra, and many faculties and students, they have shown a great enthusiasm. So that's why we were able to organize so quickly this meeting. Okay, and I thank them all for their dedicated effort to organize this. I am also very much thankful to Professor Vasudev Rao, because he actually conceptualized this idea to organize various kind of interaction meetings, okay, for with CI and OCCs, and as told by Professor P.D. Nayak, that the first meeting on basic sciences organized during 6 to 8 April 2022. And then the next meeting was organized at SINP, that is on condensed matter physics. But if you see in those meetings, the interactions were mostly, the lectures were organized mostly, many lectures were online, some were there offline also. Most of the faculties were attending online, and virtually there was no presence of students, in-person presence of students. So we thought that we should organize a life sciences interaction meeting where all the faculties and students will come physically. So because now we know, after this COVID time, we came to know what is the difference between online teaching, online learning, and offline teaching, offline learning. So it was a kind of, that's why a little bit strict, that many of the faculties probably have felt that we are not allowed them to present online. But we strictly followed that, yes, all the faculties and students should come to the lecture hall, so that the interaction will be, actually there will be a very strong interaction. So this present interaction meeting is a first of kind in the HBNI family. Why I want to say is that because of this is now all the people are coming offline, all are present here. Okay, and also we have organized, there is a now broadcasting of this thing, live broadcasting in all our campuses. So those who could not come due to other reasons and limitations, I think they will also be able to enjoy the scientific deliberations. And in this meeting, we have we have given a lot of importance to students. We have kept a lot of time for them. If you see the today and tomorrow, 50% of the time we have kept for students. The whole afternoon after lunch, it will be the students. So their students will be strongly interact with all other students from other campuses, also from the faculties of the all institutes. That will be, the students will be highly benefited. Not only that, because of these interactions also, there will be a strong interaction of all the faculties from all campuses, because they are here. Now coming to, let me tell about my experience because I'm from a chemistry, I'm a chemistry person actually, synthetic organic chemistry person. So of course we know a little bit of application of chemistry in biological sciences. And as I was associated with bioscience group, so I had some idea about what type of researches are going on in bioscience group. After joining HBNI, as a associate dean in life sciences, I also came to know what all these our CIs and OCCs are doing through their thesis, the thesis of the students, the synopsis of the students, the reports. So I have also, may not be the full idea, but I have some also kind of idea what are the type of research work going in various these institutes. Like in case of, I will say that in BRC, I think there is a major emphasis given on the crop improvement program, okay, and effect of radiation on various biological systems. I am not telling these are not exclusive, but there's a lot of emphasis has been given. So research are directed in this, in these directions, and also on the food safety. Of course, if you want to do all the research, you have to do a lot of other basic research also. Similarly, if you see the TMC ACTRED, they are fully devoted to cancer, starting from the early detection to treatment. If you see the IMSC, because they are dealing with the mathematics, but if you see their research, they are developing mathematical models, algorithms, and also they are trying to correlate the information available in other areas of science, like chemical sciences, or let us say natural products, and they are trying to correlate all those things, how they can be used in life sciences. So that's a very good, interesting thing. One can use those informations and their expertise while designing various research programs. If you see the SINP is working on the development of biocomputers. And then they are also working in other areas like cancer and many more fields. If you see the Niger is a wider research activities. And Niger, if you see, they have all the departments like physics, chemistry, mathematics, computer science, biology. So they have a very strong academic kind of research program. And also, if you come to RRCAT, if you see, they are mostly working on detection and diagnosis, okay, of biological and chemical events using lasers and accelerators, okay. And also they are developing novel spectroscopic techniques so that one can use in all kinds of sciences, in material science, one can use in medical science, life sciences. So I think many of you will be very much interested to see how they are doing their research. So what is we are expecting? We are expecting that all the faculties and students should closely interact. That interaction is very important. Now, see, we know that HBNI is so many institute or campuses where life sciences research is going on. Okay, but we rarely follow what others are doing. Maybe some very interesting research report or publication come, we read it. But actually, if you see a publication is a very small information, we put only the positive informations. We never put the negative things there. But when you interact, you will come to know what are the problems they face and how they solve that problem, and whether the new ideas which all of you will be presenting, so they can have new ideas to solve their difficult problems, or maybe new ideas will generate. That is the most important thing, and that will result to many new collaborations, okay. And it may make new life sciences programs so that you can collaborate. The another advantage is that because it is happening only with you see here, we are all from HBNI. So it is easy if you want to make a collaboration, 2 institute, 3 institute, or even all 6 institutes, you can do it very easily because HBNI is involved. So you don't have any other administrative difficulties. So that is another advantage of interacting and finding out new collaborations. Now, you may ask that how this RRCAT was chosen as the host. Okay, so this selection of Raja Ramanna Center of Advanced Technologies as the host was decided in the first meeting of all these dean academics of all CIA and OCCs, and Raja Ramanna Center came forward to host it, and all the CI and OCC has agreed for this choice. In fact, all 6 participating institutes, they wanted to host the program. And I think we'll keep on doing such programs in our future programs. There will be such programs in other OCC and CI also. And we'll use this meeting as the model for the future meetings. That is our goal. So beside these interactions and lectures, you will visit the labs of the RRCAT. And I think that will be also a very interesting and exciting because you will see the very sophisticated facilities there, and maybe you will be able to think about solving your difficult problems in a much simpler way. So again, I welcome you all in this interaction meeting and wish you all a fruitful interaction, great time, and a comfortable stay. Thank you very much.
Thank you, sir. Now I request Dr. Satyaram Mishra, Dean Academics HBNI at RRCAT, to kindly come and say a few words.
Honorable Chief Guest of today's function, Professor Mlanje Paul, Director UGC DAE Consortium for Scientific Research Indore, Dr. Shankar Nakhe, Director RRCAT, Professor P.D. Nayak, Dean HBNI, Professor S.K. Ghosh, Associate Dean HBNI, and you can say mentor of this event here, and Professor S.K. Majumdar, convener of this meet, dignitaries in the hall, Professor Hassan, Professor Prasanna, and other senior colleagues of RRCAT. I'm very excited to see this meeting being here, organized here at RRCAT. Actually, when I came to know about the HBNI program for organizing theme meetings, so I came to RRCAT after visiting BRC, and then I discussed with our director, Dr. Nakhe. He was very happy and supportive to organize this type of theme meetings. So idea was seeded from there. And then we discussed about from where to start. So it was chosen that we will start from life science theme meeting. And so it is here today. I hope we will organize other meetings also in other disciplines of physical sciences or engineering sciences in future. And actually, HBNI as a whole, I view, in my personal view, is not only university. It is a body which is promoting excellence in science and technology across our department and across the nation. So with this theme meeting, I think that purpose will be served to some extent because many CIs, faculties are here, students are here, so they can interact, generate brighter idea, and develop science and technology for the national progress. In RRCAT, there is a vibrant group in life sciences about biophotonics led by Dr. Majumdar, and who is working on various aspects of biotechnologies, biophotonics. And to name some few, his group has developed point care instrument devices like oncodiagnoscope, tuberoscope, Neil Bhasmi, etc. So these devices are nowadays practically used in hospitals. They are also gone under transfer, technology transfer. So they are indeed contributing to the national health programs. There is also considerable efforts in the direction of detection of food adulterations, adulterations in edible oils, in dairy product, pharmaceuticals. So these are the programs led by our biomedical division, and this is going to be really fruitful in the future programs of RRCAT. As you know, RRCAT is Center for Lasers and Accelerators. So in accelerator side, the contribution comes from a food irradiation facility which is installed near Chetram Mandi here for irradiation of agro products and to enhance the lifetime of the agricultural products. So I hope you will be visiting these labs as well as this food irradiation facility during this meet and get idea of the what is going on, which may be beneficial to all the participants for their ongoing research programs. So we also look forward to exchange here our ideas with the others, and hopefully after this event there may be some kind of student exchange program which may be helpful for the overall development of HBNI and CIs across the HBNI, and which is the need of our, because facilities are scattered. Some facilities are better at one place and some facilities are better at other place. So interaction and exchange programs may help the student to do excellence in science and technology. On this occasion, I wish to record my sincere thanks to HBNI Central Office, particularly Professor Vasudev Rao, VC of HBNI, Professor P.D. Nayak, Dean of HBNI, who is present here, Professor S.K. Ghosh, Associate Dean, Professor H. Paul, Professor Maiti, and other colleagues of HBNI who have actually supported in organizing this event here at RRCAT. So I have a very special mention to Dr. Majumdar for taking all the pain to organize this event, and he has done really hard work during a very short notation of time. So I think he deserves a special applaud for that. So this type of theme interaction meeting will definitely encourage us, and it will boost our biomedical activities at RRCAT. In future, hopefully we can organize in other disciplines also and get benefited out of it. I would also like to thank our Honorable Director, Dr. S.B. Nakhe, whose constant guidance and support was there from the beginning, from the conception of this event, and thank you for that. Finally, I thank all the participants who have made who have taken a trouble to reach the RRCAT Indore in spite of their schedule and made this event as a success. I hope your stay, who are coming from outside, may be comfortable. If there is some difficulty, my apologies for that, and we will try to keep you as comfortable as possible. Your participation in this event should be hopefully fruitful and memorable one. I thank all the dignitaries who spared their valuable time for today's function. Thank you, one and all.
Thank you so much, sir. So now is the time to hear the words of wisdom of Chief Guest of today's ceremony, Professor Amlanji Pal, Director, UGCDAE Consortium for Scientific Research, Indore. However, before I invite him to the podium, I request Dr. Majumdar sir to please introduce him to the audience. Please.
Good morning again. Professor Amlan Pal, though doesn't need any introduction because he is a stalwart in the field of condensed matter physics. but still, it will be my pleasant duty to introduce him to the audience, this audience who is not aware of his scholarly eminence. Professor Ramlan Pal is currently the director of UGC-DAE Consortium for Scientific Research, Indore. He is the director of all the centers of DAE-UGC Consortium. And he is a J.C. Bose, Jagdish Chandra Bose National Fellow at the School of Physical Sciences, Indian Association for the Cultivation of Sciences, Kolkata. Professor Pal received his MSc and PhD in physics from University of Calcutta and Jadavpur University, respectively. His research interests include device physics, materials engineering leading to organic electronics, solar cells, spintronics, topological insulators, and so on and so forth. He, along with his PhD students, has published more than 250 papers in international journals and has guided over 27 PhD theses. He is a fellow of all the 3 science academies of India and the Indian National Academy of Engineering. So there is a long list. I will not go in detail. So with this brief introduction, I invite Professor Pal for his address.
Thank you for the introduction. Namaskar, and namaskar to everyone. Dignitaries on the dais, Dr. Shankar Nakaji, Director RRCAT, then Dr. Naik, Dr. Misra, Dr. Ghosh, and of course Dr. Shobhan Majumdar. And of the dais, many dignitaries here. Special mention to Professor Annie Hassan, who will be the keynote speaker today, and we all are waiting for her speech. Well, thank you again, Dr. Nake, for inviting me for this to be the chief guest in this occasion. So I understood that this is HBNI theme meeting on life science, and as you have seen that I am a Cornus butter physicist, experimentalist. So, and I have worked with PhD students throughout my career. And this theme meeting on life science that is being held here at RRCAT. And if I look at the objective, as you sent me, Dr. Nake, that is to create a platform for the faculty members and research scholars of different constituent institutes, which you call CI, of HBNI, to interact amongst themselves to facilitate knowledge and resource sharing in the broad area of life science. But you already had some meetings on condensed matter physics at SINP, similar meetings, I would say. So the basic idea here is to have this kind of a knowledge and resource sharing. And since I am a researcher, and I am still a researcher today, even if I am a director at UGC-DAE CSR, so I feel from my heart is that this resource sharing is very, very important, especially for students and also for faculties. And as you know that at UGC-DAE CSR, the mandate, so we are institute, we are autonomous institute of UGC, and the mandate of this UGC-DAE CSR is actually resource sharing and collaboration between different places. So I will come to that. So at UGC-DAE Consortium for Scientific Research, which we abbreviate as UGC-DAE CSR, so it was formed by Memorandum of Understanding between Department of Atomic Energy and University Transformation. So initially it was named as IUC for DAE facilities, and then with the guidance of Dr. Kakotkar, in the year 2003, it was renamed as UGC-DAE Consortium for Scientific Research. And we have 3 centers at Indore, Mumbai, Kolkata, and 1 node at Kalpakkam. and the head office is at Indore, where I sit. So what we do actually at UGC DA CSR, and why UGC? So we are funded by UGC, but DA gives us more than money. So I will come to that. So what we do actually, and why UGC formed UGC DA CSR? Because through UGC DA CSR, university researchers from where our students, all of us actually came at any point of time. We studied our BSc, BTech, MSc, MTech somewhere in some university. In some places, it was a remote university. So if you think of those universities, now we are here at different DAE labs, so which I call endowed places. Even where I am from, Indian Association for the Cultivation of Science, these are all big institutes. But think of those universities, those colleges where from we graduated, we did our bachelor's or master's. They are really in bad shape. So how we can help those places, those small universities to carry out some kind of research? I understand that they will not do the quality of research, the kind of research that the IITs are doing or ISCs are doing, ISC or ISERs are doing. But still, they should do some kind of research. Otherwise, our students which are coming to us for PhDs, they will have absolutely no idea of research if they do not see even one spectrometer or one multimeter during their undergraduate process. So at UGC DE CSR, we support those universities, not only those universities, we support also other universities, all universities across India. So the universities, so we have, what we do then, if you have time, please visit us in Indore. You will find that we have housed all sorts of high-end research facilities. We definitely have our in-house scientists who are doing PhDs, who are guiding PhDs, carrying out PhDs for their students in our in-house activities. But at the same time, more than 50% of their time are devoted towards supporting the university researchers across India, all over India. So at any point of time, any university researcher or a PhD student from the remote university can come to Indore or Mumbai or Kolkata or at Kalpakkam and do whatever research he or she wants to do without paying a single rupee. That is the beauty of this. You don't have, the student will not have to pay a single rupee to do any measurement. I just give some examples like XPS. You know that is a very expensive instrument, and the student can just carry out the measurement there without. And we actually provide the travel and the travel accommodation, everything there. So then the part is the why. What is the contribution of DA? Because the name says that it is the UGC DA Consortium for Scientific Research. So I could understand that we are paid by UGC. Our students are paid by UGC, the instruments are funded by UGC. So what is the contribution of DAE? I said that DAE gives more than money because DAE opened their labs. Like here we are sitting at Indore, we have 2 synchrotrons, and the remote university, the researchers from the universities, they can come to Indore and carry out the experiments at synchrotron. Just imagine that. And synchrotron, when I saw synchrotron first time, I know that I felt proud that yes, we can do that when I see the synchrotron. So that is the beauty that of UGC DE CSR, that the students can come to anywhere, either at RRCAT. We have 2 beamlines at here at Indus 1, that is BL2 at Indus 1 and BL1 at Indus 2. And I especially thank Dr. Nakhe because the RRCAT is now planning to provide the BL26, the other beamline at Indus 2, to the university researchers. So soon we will be able to provide support to university researchers through 3 beamlines. So we are now doing through 2 beamlines. Also at Dhruva reactor at BRC, many of you have come from BRC. So there also we have this neutron diffractometer at BRC. So the researchers from universities, they can come for this kind of measurements. Similarly for VCC and also at IGCAR. So these are the supports that we give to university researchers, and so that we can have kind of wider range of spectrum for researchers and do this kind of experiments. So I have noted that the scientists from other places like SINP, NISER, Math Science, and BRC, of course, they have come to present their work here. And as I am from Indore, I extend my hearty welcome to Indore. And in this rainy season, especially since the rainy season is getting over, the Indore is beautiful. Of course, RRCAT is beautiful campus, but please go out of RRCAT also. You will find that Indore city is really beautiful and it's truly a cleanest city in India. So, yeah. So on a different note, I would like to say that the dates that you have chosen. So these dates, you know that on 5th of September we celebrated Teachers' Day, and at UGCD ACSR we are celebrating Teachers' Day. Today we have a special talk, and also tomorrow we have a special talk from BRC scientists tomorrow. So and the dates are really good that because we all are basically teachers, because we are all dealing with PhD students, and since I have spent my life with PhD students, I just want to share what should I say, how I feel about the PhD students. So when the students they become graduate, that is they obtain the PhD. So what is the full form of PhD? I always say it's a Doctor of Philosophy. So the philosophy term is very important. That's what I do with my PhD students, because philosophy means that it is what is called darshanik. So this is our duty to make our students to be a darshanik, because when the students go from BSc, MSc, they do this textbook knowledge. They know that I have to memorize it, grasp it, write it, and get the highest marks or the best marks, so that I can crack NET or something, and I can crack a training school or something. So we all had some aims when we were studying at BSc and MSc. But there is a big difference when you come from MSc or MTech to PhD. So there you don't have kind of a teacher, so it's not a boss there. So we are now sitting together, we are fighting with our referees, we are doing new research. So what we do basically with the students, with my PhD students, I can tell, and I'm sure that you all do that we try to make them, that is, we try to make them think, because that's the first time in one's life. I feel that when they are doing PhD, they start to think that क्या करना है अभी, क्या करना है, what should I do new. So that's the first time they will start thinking that what should I do something new, because in BSc or MSc or BTech, MTech, there was very little scope of thinking. So that is the important perspective that I feel always, that for PhD aspect, when you do, we have to think that we have to make them darshanik, and then only they will become PhD, that is Doctor of Philosophy. So that's it's often said that best teachers teach from heart. Of course, we have to teach from heart, and not from the book, and we have to do that. And more importantly, the other aspect that I always dealt with my student is that as a teacher, as a PhD guide, I always teach them the difference between right and wrong. It may look very simple, that what is the big deal that to know what is right and what is wrong. But if you think seriously at one point of time when you are alone, that is the biggest difference, that if I know the difference between right and wrong and act accordingly. It's not only that I should know kya sahi hai, kya galat hai, but I have to also act accordingly, that I should never act which is wrong. If we all follow this one, that I should never act which is wrong, then you will see the picture will be totally different. So that's my feeling as a teacher, that I should try to embed this feeling, this knowledge to the student, that never do anything which is wrong. Just follow the path of right. So that's all sorts of philosophy that I thought of, because this is a theme meeting on biology, and I completed biology in class 11, so I cannot say anything after that. So I won't take much of your time, and we all are waiting to hear the keynote address by Dr. Annie Hassan. And I conclude my talk again thanking Dr. Nakhe for inviting me to come here at RRCAT. And it's always pleasing to be RRCAT and witness the huge activities. I really feel that whenever I come to RRCAT, I say that, and especially when I say synchrotron, I feel a proud scientist, a proud Indian. And I always feel that when I see synchrotron, I see that, yes, as an Indian, as Indians, yes, we can do everything. That is what I always feel when I see synchrotron. Thank you again very much, and namaskar.
Thank you, sir, for your enlightening words. Now, I would like to request our Honorable Director, Dr. Nakhi, sir, to please present a memento to Professor Amlan Pal, sir, as a token of love and respect. So moving ahead with this, now the time has come to listen to the address of the keynote speaker of today's function, Professor Q.N.E. Hassan from Kamineni Hospitals, Hyderabad, who is a doyen in the field of genetics. However, before I invite her onto the dais for delivering the keynote address, I would like to request Dr. Majumdar sir to kindly say a few words to introduce to the audience. Also, I request all the other dignitaries on stage to kindly take your seats in the audience. Please.
So again, Professor Annie Hassan, as today she is going to give the keynote address, as Mohima already told. And you know that, let me tell you something about Professor Hassan. And just she has come from Europe last week. And when I called her for this keynote address, because our the keynote speaker who was scheduled for today's listening, he had some urgent meeting, so he couldn't come. So I was having headache, you know, and very much tensed. So then I called Professor Hassan with a hope that she might be considering my request. And she told that she's now on her way back to home from airport. She has just returned from Europe. And this was on 5th. But she told that there are some problems, you know, that I cannot come. But I insisted. And it is so nice of her that she agreed. And finally she told that, yes, I will be coming, but for a day. Though we would like to have her here for all the days, because now I will tell what she is. Dr. Hassan is a senior consultant and head of the Department of Genetics and Molecular Medicine, Kamineni Hospitals, and also the research director of Kamineni Group. She is the founder member and president of Board of Genetic Counseling of India since 2014 till date. Dr. Hassan is a doyen in the field of genetics. She holds fellowship from CCMB. She has over 3 decades of experience, and her areas of interest include molecular pathology in cancer, neurodegeneration, diabetes-related complications, and pharmacogenomic-based medicine. Prior to Kamineni Hospitals, she spent 8 years in Wellington Medical School, New Zealand. She has over 150 national and international publications to her credit. She has mentored over 500 students and faculty for projects, BTech, MSc, DNB, and PhD thesis dissertation. Her goal is to set up genetic units in oncology centers, pediatric hospitals, IVF clinics, and community healthcare organizations, which are coordinated by genetic counselors. Dr. Hassan has started the nation's first full-time PG certificate course in medical and genetic counseling in India in 2007. She has been a member of a minority commission from 2013 to 2017 for the combined states of Telangana and Andhra Pradesh. She is the principal of DNB courses, postgraduate medical education, community hospitals. She has guided over 17 PhD students. With this kind introduction, I just invite Professor Annie Hassan to please come onto the podium and deliver her keynote address.
Start. Yeah. Yeah. Good morning, all of you. I have to thank Professor Majumdar for being so persuasive and charming to give me this honor and privilege to be with this august gathering. But when somebody asks you to give a talk as a theme meeting of life sciences in centers which I always thought were centers of physics or chemistry. So I thought, where should I start and how do I begin? One thing is there that most of these podiums are made for men who are tall. So I don't know whether you can see me. Do you want me to come this side? Yeah. So the first thing I did when I joined Kaminini was to get a stool near the podium. I told the management that if you want me here, then I want to speak. And when I want to speak, I want to be seen. So every Kaminini institution near the podium has a stool for us to stand on. So anyway, so I thought I will talk about the genomic era because I know most students who come to me, and I'm sure all of you, the faculty sitting here will also know, that when they come to us, most of the students want to do research on cancer. Do you agree with me? Most of them when they come. So I thought I should talk about there are several other disorders which we need to study on. And now how do I begin about the genomic era when I want to explain it to people from mathematics or physics or chemistry background who are all august faculty members here. So I thought the best place to start is the very beginning. As the Sound of Music song goes, so we start with. फिर मैं कहाँ लगाऊं इसको? कहीं लगा दूं? It's not. How does this go? This one. No, I want to go to the next slide. Can I do here? Should I do it on this? So what we can talk about is that I have been trying for a long time to differentiate between testing and counseling. Tests are what the scientists have worked on, they have developed over the years, the technology has been developed, and now it has come to the healthcare setting. And India is at a very crucial step where we are trying to get genetic testing into mainstream healthcare. Is it working? Yeah, okay. So when we start at the very beginning, what happens is the sperm and the egg have the genetic material, and the genetic material, which is this haploid set, is known as the genome. Now, this single cell, the zygote, has all the information that. Am I doing something wrong? It's here, no? Where do you want me to put it? You want me to put it here? How come everybody else was doing well and I am not? Yes? Okay. So every cell of the body gets the whole genetic material. My sari is the culprit. So what do I do? Can I talk without it? Do you think I'm loud enough? Yes. Okay, so can I get rid of it? Because I can't get rid of the sari, so I have to get rid of the mic. Only the last.
Hello.
Okay, so now we have the cell. The cell has the chromosomes. The chromosomes are made up of DNA and protein. And any variant which you see in the DNA is reflected in us. Either it is reflected to make us unique, or it makes us get a disease. So now the genome, the gene, both have variants, and these variants are very important for all the traits, the way we look, the way we behave, and this is the basics. After the Human Genome Project, human beings were very disappointed that we have only 20 to 20,000 genes, which is more or less equal to the number of genes in a mouse. You know, we thought we are superior, but then what is it? We have the same genes as a mouse. So that's what. But anyway, we know that we can study the DNA, we can study the chromosomes, and now these tests are very easily available to do what we need to do. Variations make, give us a eye color, a height, our intelligence. And the best thing which happens in India is that if you want to hear how many faults you have, please have a child. They'll tell you, oh, the nose is like the mother, big, small eyes like the father, bad temperament like the mother, a smart tongue, correct? So all the faults you can get comes from the parents and the families. But then there are various other things which we get because of acquired traits. Like you see in the cartoon, the father and son are carpenters, so their biceps may be more developed than others. But that is not so much due to the fact that it is genetic, but also the fact that they've been using their hands more often. One important thing is, this is my father, me and my son. Most clinicians think that certain diseases go only from the female line, like breast cancer. They think that if a mother has breast cancer or the maternal aunt has breast cancer, then it will go. It's not so. It can be the paternal aunt and the carrier is the mother. So like in this picture, I wanted to show baldness. My father is bald, and I may be passing on the gene for baldness to my son without being bald myself. So this is something very important which we need to know, that there are certain traits which may be missed because of the sex hormones, but genetically they are passed from the parent of origin. It can be a father or mother. Lot of variations like height, eye color, skin color. But remember, we know that multiple genes are responsible for our height. But can you imagine, I have a potential to become 6 feet tall, but I am deprived of good protein nutrition in my formative years because of malnutrition, then I cannot reach my full potential. So that's why the phenotype which we see can be a mixture of genes and environment. But again, if there is a mutation in FGFR gene, irrespective of the other variants, you will be achondroplasia or a dwarf. So that is where the importance of genetics comes. Which genes are playing a role? Is it a single monogenic variant or multiple genes? Like when we are looking about diabetes, cardiovascular disease, asthma, we are looking at multiple genes. But if you are looking at thalassemia or oculocutaneous albinism or achondroplasia, looking at a single gene. So genetics is important for both health and disease. And I'm sure you all are aware that it has been adopted even by the Olympic Committee that they will do genetic tests. Before they used to do genetic tests only to do male and female. I don't know how many of you are aware, but I have got people coming from Indian Olympic thing where we just need to do the sexing so that we say she goes in the female category or male category. Saina Nehwal came to us. But the Indian Olympic Association asks us to do a sex chromatin test, which is the bar body where out of the 2 X chromosomes, one gets inactivated. But that is no longer accepted. You have to do a chromosome test. I'll tell you why. Because Klinefelter syndromes can have a bar body because they have 2 X chromosomes and a Y chromosome. So, whatever you do, now thinking about COVID, we have seen it that in COVID, some people got mild symptoms, some people got no symptoms, and some people faced mortality. So why is it that the same virus had different, it was not variants which did it. It is our genes and immunity. So that again varies. Response to vaccination. People who have taken 2 doses, booster doses, are still getting infection, and there are ones who have never taken a vaccine with no problems. Now, all of us in the audience who are parents or who are planning to be parents want a healthy baby. And sometimes just looking at the images of these patients, you come to know that they are different. And that is how the whole science of genetics started. That you observed that there's a problem, and then we went about finding a gene for that. But now we go the other way around. We, in the genomic area, we have the ability to do the whole genome. And from there, we pick up variants which could be associated with that pathogenesis. All this information we have. But unless this is conveyed to clinicians, patients, families, communities, we have not done our work. We have got our PhD, we have got our publications, but we have not translated it to society at large. And that is where, from my basic research, I came to the clinical side, and I stopped working in well-equipped CSIR labs and started working in hospitals, fighting with the universities that my students who are doing good work need to get a PhD from their university. Because they did not want to accept a private hospital as a research center. So that was a struggle. which took my first 7 years. Like you said, 2007, I could then focus on genetics and genetic counseling. Till then, I was trying to establish Kaminini as a research unit acceptable by universities so that the work done there could be awarded. Because see, what does a student want? They are ready to work, but they do want their own PhD. Otherwise, why are they going to work with us? So what? So then we thought how best to bridge this gap of the available technology for tests, the clinical information of the disease, and the patient and family which are suffering. And having genetic disease means it can come to other family members or other community members. So this is the whole concept, that whatever the magnitude of the genetic disorder should be conveyed. And we developed genetic counseling as a profession in India. Of course, it was there in the US. And even today, US and Japan are the only two countries in the world where the genetic counselors ratio to population has reached what is the accepted standard. No other country in the world has done it. UK is struggling now. I'll tell you that later. But so we give you the information and also talk about how this genetics could help the health of a particular thing. Now, whom to counsel? Earlier, it was thought only genetic diseases affected children at birth. So everything in blue was something which genetic counselors could deal with. But now we realize more and more we are getting neurological cases, muscular disorders, cancers and hematological disorders, and common diseases like diabetes, cardiovascular disease, asthma. As the knowledge is advancing, as the technology has advanced, as the bioinformatics has increased, we are getting more and more information how to handle these diseases. So what we do is we do pre-test counseling. I don't know how many of you, the students may know it, but once upon a time in India, we used to have a family physician who knew the family history of, and they would say, oh, I know the grandfather had this, the family had some psychiatric problem or something, or that one died of this disease, or they had a liver cirrhosis, or whatever. Now, clinicians just cursorily ask, is there a family history? Now you tell me, how often would we like to tell that we have all this in our family? We'll say, nah, nobody has it. So the genetic counselor is the one during the pre-test counseling takes a family pedigree and understands the main concerns of why the person has come to you. If they have come to you for pre-pregnancy counseling, you have a different question set to ask. That why have they come? Like I'm from Telangana. In Telangana, we have a lot of consanguineous marriages, which is Maina Mama, Maina Rikam, we call them, uncle-niece marriages. And in Muslims, we have cousin marriages. In Telugus, we have Maina Mama, it's called, uncle-niece marriage. Now, why are they coming to me? Because they may have seen some children suffering from some disorder and they don't want their child to have it. But because of the custom, that's the cultural custom, they educated people have Googled it, that okay, consanguineous marriages result in disorders. So they come to you and ask. On the other side, the parents come to us saying, tell them there's nothing and they'll let them get married. So the point there is that the concerns are right, that consanguinity does increase the chance of autosomal recessive diseases, but it doesn't increase if that gene is not there in the family, correct? And two people who may not be consanguineous. If this was the case, then all developed countries would not have autosomal recessive disorders, but they have it. So that means sometimes founder genes are there in the population. So what we need to do, everybody says genetic tests are expensive. You didn't even ask me what was the cost. That's what I tell clinicians who tell me, but genetic tests are expensive. Did you ask me? No. Did I tell you that this is the cost? The costs are coming down. And remember, genetic diseases doesn't mean that we always have to do a genetic test. We should do a genetic test if it has value for subsequent testing. Like if the pedigree, we just take a pedigree, and like it is said that after Einstein passed away, his wife was invited to inaugurate some lab in Germany, a big physics lab with all kinds of equipment and everything. And we went, she goes there and she sees it and she congratulates them and all that. And then the person showing her around says, "Ma'am, we have got all this here to understand how things work." So she said, "Oh, do you need all this to understand? My husband just needed a back of an envelope and a pencil, and he would think about it and do that." So E is equal to MC square came like that, not with equipment. So same thing. The cheapest test which a genetic counselor uses is a pedigree, a paper and a pen. But the time to ask the relevant questions. Now, consanguinity. Why is it important in India? Because of thalassemia. The thalassemia is one disorder which other countries of Mediterranean region, even countries like Iran, have been able to control and prevent it. And why didn't India do it? That is mind-boggling. So we have high-risk gene for thalassemia in the Gujarat, Mumbai, Maharashtra belt. We have it in Odisha, Andhra, Telangana belt, and we have it in the Punjab, Sindh region. So this founder gene is there. So when we did a study, we found that 46% of our thalassemic children who require blood transfusion every 2 weeks. Can you imagine the burden on the healthcare, burden on the family, burden on the patient, a child who has to go repeatedly for blood transfusion? Now, even if you give them free blood transfusion through Rotary Club, Lions Club, all that, can you imagine just going and how is the schooling affected? How is the parents' work affected? Which employer is going to give them leave every 2 weeks for 1 day to go to a center where there's a transfusion? So there's a lot of psychosocial, cultural, economic issues apart from the health issue. And then if you see, 44% are not born to consanguineous couples. So these are people who have married and suddenly are born with a child with thalassemia. If they are consanguineous, okay, the doctor says you married in relatives and puts the blame on you. That, okay, you did it wrong. So they are poor parents feeling guilty about something they were not aware of. Now, can you imagine a second child being born like that? That is the failure of the medical system. Because we have treated them with transfusion, but not informed them that this is genetic, there's a recurrence risk. Without doing the test, we can say there's a recurrence risk of 25%. So that they're aware. Now we know we can do prenatal testing, we can do amnio, CVS. For doing all that, we may need a molecular test. But before that, we just need a simple HPLC, HB electrophoresis, all of these have been developed and they are there in our country. Or similar cases, sickle cell anemia, which is very common in our tribal populations. So that's what I said. For every diagnosis, we do not require a genetic test. You may use some. This is a pathology test, this is a biochemistry test. Another disorder, MPS, mucopolysaccharidosis. The chemists and the biochemists sitting here, you know the pathway. The disorder shows similar things. There's coarse features, all that. But there are 7 different genes causing it. 2 of these disorders can now be treated with enzyme replacement. And One of this is X-linked recessive, whereas 6 of them are autosomal recessive. Now, the simplest test is an X-ray. X-ray of the spine shows beaking, and it's a progressive disorder. So this is the worst form. We are showing it a 7-8-year-old baby. But if you show earlier, this baby, can you make out? No, it looks like a normal baby, slight abdominal distension. But as it progresses, it becomes like this: short statured, coarse features, hearing difficulty, clouding of cornea, all that. From the pedigree, we can make out this is MPS II, because if it is seen only in males and so on. A simple pedigree analysis. But if we want to know whether enzyme replacement is required and all, then we do the molecular test or the biochemical test. If they are planning a next child, we have to do a molecular test, because only after doing amniocentesis, when we get the unborn child cells, that cells can be used for the testing. So now, this picture is of a couple who had their first child. This is 8 years old, 6 years old. 8-year-old child with MPS. In 2008, they came to us. And I said, oh, when you knew you had one child with MPS, why didn't you do prenatal testing, amniocentesis? They said, we did it. And then the report was normal. That's why we had the second child. I said, what? When I looked at their records, like your expression, exactly, how did this happen? What happened was the gynecologist sent the test, took out the amniotic fluid, sent the test to a lab for prenatal testing. They did a chromosome test. Chromosomes were normal. This is not a chromosome thing. You need to do the molecular gene test. And the first child had a molecular report because they had the first child while they were in the Middle East, and they had sent it to Germany and the report was there. You see, this is a case of taking amniocentesis as a test. Amniocentesis is not a test. Amniocentesis is like taking a blood sample. It's a sample collection method. But they didn't think about that. They were not told. They were not explained. They thought once they've taken the fluid, everything should be fine. The gynecologist was not aware that there's a difference between a cytogenetic testing and a molecular testing. She thought it's genetic means chromosomes. So that is where we come. So the genetic counselors help in choosing the right test. And the number of tests are increasing every year, and that's how. So the tests are so many. And with the increase in technology, with the increase in thing, more tests will come up. So how do you expect a clinician who has trained in 2000 and over the years is an experienced, best clinician to know this? Because he or she was not taught about it, because those tests did not exist at that time. So that is why it is very important, because of in this genomic era, the evolution of advances in science and technology are increasing. We need genetic counselors who will act as liaison for informing people. Cytogenetics is quite prevalent in India, and many labs are available. It is still a good test for several things, for infertility, children with dysmorphology, and so on. Cancer hematology. WHO has said that hematological cancers, that is blood cancers, and leukemias, lymphomas, if you are not doing a cytogenetic test and treating them, you are doing a disservice to the patient. Because every cancer has a driver mutation, and that mutation, if targeted, will give the best result. All of you working in oncology will know about targeted therapy and so on. Other thing is, more and more, we are having cancer survivors, uh, seizure, people with seizures and all, who are coming to have children. And we do a simple cytogenetic test to see if there is damage to chromosomes. Can you see damages? If damages are there, we know that we are not taking cells from the ovary or the testis, but peripheral blood acts as a surrogate marker because bone marrow releases the cells every 120 days. And similarly, sperms are also formed in that cycle. So if we see aberrations here, we are bound to expect aberrations there, and we ask them to wait for some more time, that the effect of their treatment, like TB treatment, you ask them to take for 9 months. And if we, after stopping it, they're planning a pregnancy, we say, just wait, we'll do the test, and we will be able to tell you that maybe you need to wait for it longer. This also is seen in smokers, alcoholics, and so on. Primary infertility. Now, getting a cytogenetics report is one thing, and counseling the patient about it. If you get a Turner syndrome, which is an individual with one X chromosome, these girls don't attain menarche, and if they come to you early, you can put them on hormonal therapy so that the uterus, although hypoplastic, can be maintained for them to have children in the future. But what happens in India is they don't come to us at that time. They come to us when they're about to get married. Now imagine they've come at 18, 20. Already the streaked gonads become atrophied and the uterus remains hypoplastic. And now, can you understand the stigma and in an Indian patriarchal society for a girl who gets married and cannot have children? So it affects the whole family dynamics. And that's where counseling comes. And counseling is totally different at which stage they had come to you. The chromosome report is the same. So that's why we talk about testing and counseling. Similarly, Klinefelters. A male comes to you. Can you imagine the trauma the person feels if he's already married, that he's been identified as having XX, 2 X's and a Y? When he has a wife, he has all kinds of things. He is now developing gynecomastia. So the counseling in each of this is totally different if they are married, unmarried, and so on. Similarly, many times when we look, this is, I think, all of you must have seen in your 10th or 11th class books, Down syndrome. Down syndrome child is easy to identify, and that's why many clinicians say, why do we need a test? We can make out it. The reason we need to know the test is because of recurrence. If it is a free trisomy, that means 1 extra 21, then the recurrence risk is very low. Next child be having it is low. But if it is a translocation, then the recurrence risk is high. And that is the reason why we need to do the thing. Another test is FISH. FISH is if we know which chromosomal region is deleted or increased, then there is a technique which we can look at the pattern. So we do FISH. You can just take the cell, put it on a slide, put the probe, that is, if we want to see Down syndrome, then we put chromosome 21 probe. So here in this slide, I have got 2 red signals, 2 green signals, and 2. This is chromosome 21, 13, 18. But if you see this cell, it has 3 reds. That means this baby, fetus from which we took amniocentesis, is normal, whereas this has Down syndrome. So we can tell this prenatally at a very early time point for them to take a decision. FISH is used a lot, especially in breast cancer. Here, ER, PR, HER2. I'm sure some of you must be working on triple negative breast cancer because triple negative breast cancer does not have targeted therapy. If it is ER/PR positive, then we have therapy available, endocrine therapy. If HER2 is positive, then we have got Herceptin therapy. So this is targeted therapy we can do. But the first targeted therapy which started in cancer was for leukemias, CML, chronic myelogenous leukemia. If there is a chromosome 922 translocation, it forms a fusion protein, and against this fusion protein, we have a specific treatment, Gleevec. But if this fusion is not there, then you don't treat with Gleevec, you treat with hydroxyurea, other things. Now, why is it that oncology treatment is not followed upon? Many people give it up because of the complications. We all know that what are we doing in chemotherapy? We are giving drugs to just destroy all dividing cells. And all dividing cells means follicle cells of the hair, the nails, the whole of the skin, whole of the internal lining which is dividing. So all this get destroyed. That's why you get vomits, diarrhea, rashes, hair loss, everything. So, but if you do targeted therapy, you do not get any of these complications. I myself know various people who have started on Gleevec therapy at least 30 years back and are alive today doing their duties without any problems. So now, if the change we do not know, like we knew that there is 922 and all, we do fish. But if we do not know, but we are suspecting that there is some minor change, then we do a technique called CMA, chromosomal microarray. A child came with certain features. We were not able to find out delayed speech, delayed thing, drooling, all kinds of. When we did it, we found that the child had a chromosome 2 deletion, and that caused all the features of the child. Now we can look whether the parents have a balanced translocation of that region. Will they have another child like that? So CMA is the technique. But remember, CMA can assess only gains and losses. So if there is a translocation which is balanced in the parents, then we have to go back to do fish. You don't do CMA again in the parent, because CMA cannot tell you. So choosing the right test for the right person is very important. When to choose fish and when to choose CMA. You do ultrasound. I think I was speaking to one of the students this morning who's doing work on growth of fetal growth. So, yeah, you algorithms. Now, fetal growth algorithm, when the fetus is small or has cardiac issues, then it can be Down syndrome, Turner syndrome, DiGeorge syndrome, Wilson's disease. Now, which test to do for amniocentesis? That's when we decide. If we see any other features along with it, then if it is something NT scan, like you were doing a 12 or 13 week scan, and we find that the NT value is higher than that, then we will do for aneuploids. That is, it will be 21, 13, 18, X and Y. Now, coming again to the cultural aspect. India, we do not want X and Y because it's illegal to do fetal sexing. So our hands are tied. We cannot do that. But we try to do 13, 18, 21, and we say sex chromosomes. We are not supposed to say what it is, like that. Then we have innumerable molecular techniques, which I'm sure all of you use in your labs, the PCR. A simple PCR can give you a lot of answers. So you can do single gene, multiple genes, clinical exome, whole genome. Can you imagine having a baby and a doctor is not able to tell you the sex of the baby? In the Indian scenario, they don't even ask how the mother is, what is the normal delivery, they'll ask is a boy or girl. Correct? Now, if the doctor says, I don't know whether it's a boy or girl, it's a real trauma. So that time, we just take a buccal smear quickly, isolate DNA, and look for the SRY gene. If SRY gene is positive, then the testes may be undescended, but they are there. So we can safely say it's a boy. If SRY is not there, then we say it's a girl. So we do it, that's a quick test, single gene, one area, present or absent. Finish. And this doesn't cost much. But sometime they don't say it, they just send the child away, or they just write mails to make the family happy, and then they come after 3 years or 4 years with some issues. Then it becomes a problem because the testes have been in the abdomen for so long that spermatogenesis doesn't occur, and then the child becomes infertile, male infertility. So this is important to be done at the right time. Blood pressure, my God. I think half of India has it, correct? Now, what causes it? There are multiple pathways. One of the commonest is the angiotensin converting pathway. And in that, we know that there is a single insertion in this ACE gene, and this insertion and deletion. If there's a deletion, then you give them ACE inhibitors and the BP will be controlled. But if you are doing trial and error, then you may give ACE to a patient for, the doctor gives and says, Acha, come back after 3 weeks, it's still not under control. Then they change it to another, or they add another medicine. So that is like trial and error. But if you do the gene test and do it, and this we are doing in Kaminini, especially for stroke patients who come with high BP and vessel hemorrhage. So immediately we know which medicine can be given to bring their BP under control. Children with neural tube defects, early stroke, and various cardiovascular conditions, MTHFR, folic acid. Folic acid has been talked about a lot for maternal mortality in India and also for children with congenital defects. And Dr. Chandak from CCMB is working a lot on folic acid supplement and this. But remember, folic acid affects both males and females. It's not just for pregnancy. And that is why if there is a variant in this MTHFR gene, it can be normal, it can be heterozygous or homozygous. We need to supplement these individuals with B6, B12 folic acid in high amounts so that we prevent. So this comes in preventative genetics. Now, what are developed countries doing? USA and UK have added B6, B12 and folic acid in their flour. क्योंकि वो लोग ज़्यादातर ब्रेड खाते हैं, बिस्किट खाते हैं, केक खाते हैं, सारों में फ्लावर यूज होता है. So they have fortified their flour with B6, B12 folic acid for preventative. So that's a public health program. And that's why when Sir was talking about public health, I was thinking, public health genetics is very important for countries like ours, where we do not have access to all kinds of health. Can you imagine a stroke patient? If he ends up with a disability, loss of man-hours, loss of family, because he's maybe the only primary breadwinner of the family, and it has a lot of high-end, in US and all, what happens is they do everything with economics and they compare it and finish the public health program. Here, we need to know the epidemiology, we need to do the public health, and then we can come back. This is one more thing, DMD, Duchenne muscular dystrophy, where young boys have a defect where their muscle gets wasted. They are happy, normal boys till the age of 5. It's about 5 or 6 years, they start falling, they can't complain about climbing steps, and gradually by 16, 17, they become wheelchair bound. The muscles of the heart get affected, the lung muscle get affected, and they pass away by 2022. And the test for this is totally different. You may do the most high-end test, which costs 40,000, but this may not be detected because you have to do MLPA. It is a large exon which is deleted, sorry. Large exon. And one more important thing is that it is X-linked recessive. So boys are affected with the mother passing it on. So one, the guilt of the mother. Two, the blame of the whole family on her. Because of you, this happened. And three, the sister may also be at a risk of passing it on unless you do prenatal testing. And all this has to be explained as soon as we diagnose the child. And this is no longer a rare disease because in Chennai, they did a door-to-door camp, not sorry, Chennai, Tamil Nadu, they did a multiple district door-to-door study, and they found that DMD there is 1 in 3,000. And according to India, rare disease is anything which is less than 1 in 5,000. So 1 in 3,000 means it's no longer rare. That means we really have to know so that our young boys don't suffer. And also, the mother who's passed it on can get cardiomyopathy. So as soon as we find a child like this, we also put the mother on surveillance for cardiac disease. Of course, NGS. The technology comes from you all, and then the bioinformatics comes from you all. And what we do is we try to tell when to do a panel test, a single gene test. That's what we write to the company when it's translated. A 25-year-old male came with multiple fractures and total bone bending. Very difficult to walk. We did it, and what we found was he had a variant in the CLCN7 gene. And what was important when we learned was that his sister was married and having a child, and her gait was affected. They didn't say that she had fractures. They said, "Wo ajeeb sa chalti hai." That was it. So we said, could we talk to her? We called her. We just did this targeted mutation in her, and it was there. And then we did prenatal. The baby did not have it. And during pregnancy, she had 2 fractures. Till then, she didn't have it. But in weight bearing, she started getting fractures. So because he was a male, maybe he was doing more physical activity and he got fractures more earlier in life. But then at least that family we could help out. Cell-free DNA testing. Now we don't need to for tumors. We are doing cell-free DNA testing for lung, especially lung cancer, breast cancer, residual disease. We don't need to take the biopsy again and again. We can just take the blood sample, and in the blood sample are tumor cell DNA, and that tumor cell DNA we can study. I hope I'm not going beyond my time. So now I told you we were doing amniocentesis. Now with cell-free DNA, we don't need to do amniocentesis. We can just take the mother's blood sample and do for Down syndrome, Edwards syndrome, Patau syndrome, because fetal DNA is there in maternal blood. Hereditary cancers. The most common which people know about is the hereditary breast ovarian cancer. And thanks to Angelina Jolie, it has become more publicized and more popular. We call it the Jolie effect. Those of you from ACTRAC may have heard Rajiv Sareen talk about it a lot. He calls it pre-Angelina Jolie, post-Angelina Jolie, and talks about things. Now, but the question is, whom are we testing? We are testing people who can afford it and come and say, I want to get it done. But we have to test people who need it. And how do we find this? Who needs it and who's testing? Again, it's a simple pedigree. This individual came to us 29-year-old with ovarian cancer. When we took the history, mother had cancer, aunt had cancer, another, you see this, you can see the pinks and the yellows. The pinks were breast cancer, yellows were ovarian cancer. Apart from that, another indication is when you have the histopathology. And if they are ER/PR HER2 negative, they may be BRCA1 positive. If they are BRCA2 positive, then not only females, but males of the family need to be tested for prostate, because prostate cancers, otherwise screening starts after 50, but in these individuals, they get prostate cancer by 40, 45. So it's not just that because there's only, and also they may get pancreatic cancer, and now they're saying GI cancers. Coming to personalized medicine. Every drug we take, even for cancer, if you are giving them ER/PR positive and we are giving them tamoxifen, for tamoxifen to get metabolized, you need CYP2D6 gene. If CYP2D6 is altered, then instead of getting benefit of the endocrine therapy, they get adverse reactions. So first the patient has cancer, second you are giving a treatment, वो treatment से problem. So there is a saying ना, मर्ज बढ़ता गया जूं जूं दवा की, दवा के साथ और problems. So planning it. Same with colon cancers. When you give fluorodeoxyuridine, we always do UGT and DPYD testing. I have known of patients dying of bone marrow separation when they were being treated for colon cancer within a week. Within a week. With colon cancer, without chemotherapy, they may have lived for three weeks, 3 months. Because every drug you give has to be absorbed, metabolized, and excreted. And for each of these steps, you require genes. So that gives you the personalized medicine. That is, if you look at your DNA, know the variants, you know that this same medicine may be required at the standard dose by some, half the dose in some, double the dose in some, and adverse reaction in others. And this, I will end with an anecdote. Why personalized medicine is very close to my heart is because my son had a injury when both my sons were playing in cricket in US. I was taking a video of them and the ball hit him on his face and his teeth too went in and there was a rupture and blood and all that. But America being America, it took us 38 hours despite insurance and all to take him for surgery. Till then I was giving medicines which I had taken from here, some crocine, kept, ice pack, gave some arnica and all that and managed him. After surgery, they put him on a drug. He went into severe stomach cramps and hallucinations. I called back the surgery. They said no. His brain is injured when he got hurt by the ball. I said, no, I've got the video. Nothing happened to his brain. He was absolutely fine. Could you please tell me what drug are you giving? They were giving him Tylenol with codeine. Codeine with CYP2D6 becomes morphine. Morphine is the one which reduces the pain. He went into morphine toxicity. And that's why he was getting hallucinations and so on. So I personally feel that if we are giving especially long-term medication, it is good to know what is there. And then the question came, so we have for long-term medication, whether it is psychiatric, tuberculosis, all that, we do genes here and we tell them which they cannot take, which they can take, and so on. So this is our pharmacogenomic report. And I'd like to thank you all for patient hearing. I hope I have not overstepped my time. And these are all the genetic counselors. In 2014, we registered the Board of Genetic Counseling, and we have 200 counselors now in India. And we are now trying to encourage various people to take up teaching training programs for genetic counseling from universities, and also collaborating with the American board, the Asia Pacific board. The morning meeting I had was about that, that can we share counselors, and thanks to COVID, we also have now online counseling. So thank you so much for patiently listening, and thank you, Dr. Majumdar, for inviting me.
Thank you, ma'am, for your illuminating talk. Underlining the applications of genetics, it really gave a valuable insight into the field. Now, I would like to request our Honorable Director, sir, Dr. S.V. Nake, to please come onto the stage and present a memento to Professor Eni Hassan, ma'am.
Could you please delete my thing, the patient?
She want to delete the PPT from the screen. I have asked them to. So now we will take a break for refreshments. I request all the dignitaries to please join for the refreshments arranged at the rooftop of this convention center. And also, I request all the participants to please assemble back here at around 12:20 for the first technical session of this meeting, which will start sharp at 12:30. So, ladies and gentlemen, welcome back to the first technical session of the day. Without a delay, let us start with the session. So, this session will comprise of 3 invited lecturers. And now it will be my pleasure to invite Dr. P.D. Naik onto the stage to kindly chair this session. Along with that, I would like to briefly introduce the session chair. So Professor P.D. Naik joined BARC from 27th batch of training school and completed his PhD degree from Mumbai University in 1992. He was a postdoctoral fellow at Heidelberg University, Germany during 1992 to 93. He was instrumental in setting up various gas phase research facilities at Chemistry Group BARC before joining HBNI as Dean on 1st March 2019. He was Distinguished Scientist and Associate Director, Chemistry Group BARC. His research interest includes atmospheric chemistry, reaction control, and selectivity and interfacial chemistry. He is a fellow of the National Academy of Sciences and received Homi Bhabha Science and Technology Award in 2012. So with this brief introduction, now I hand over the mic to Dr. P.D. Naik for conducting this session.
Thank you, and welcome for this first session, scientific session. After delightful talk by Professor Dr. N.E. Hasan, we have started very nicely this program, and we'll start the first session. We have 3 speakers here, one from RRCAT, one from ECTREC TMC, and third one from BARC. The first talk is by the convener of this symposium and well-known biophysicist, Professor Soven K. Majumdar from RRCAT. He is going to talk on biophotonics for improved health care. Dr. Soven K. Majumdar received his graduate and postgraduate degrees in physics from Jadavpur University, Calcutta. After successful completion of 1 year orientation course from BRC Training School, he joined RRCAT in 1992 and received his PhD degree from Devi Ahilya Vishwavidyalaya, Indore, for his work on the views of optical spectroscopy for cancer diagnosis. He worked as a visiting scientist at Vanderbilt University, USA, where he did his postdoctoral work. His research interests primarily focus on development and evaluations of optical spectroscopy and imaging for biomedical diagnosis. His extensive research not only led to the development of the variety of new techniques required for advancing the application of optical spectroscopy for biomedical diagnosis, but also made it possible to perform non-invasive screening of oral neoplasia and automated diagnosis of tuberculosis in resource-limited clinical setting using photonic-based point-of-care instrument developed by his group. Dr. Majumdar received many awards. Notable among them is Homi Baba Science and Technology Award of Department of Atomic Energy, Raman Bhagat Memorial Award of Excellence of Cancer Care India, Swargiya Dada Saheb Kalmeg Smruti Award of Indian Dental Association. He received the 2 DAE Group Achievement Awards, Young Physicist Award of the Indian Physical Society, IPG Eminent Scientist Award of the IPG Innovative Pharmacist Group, the Excellence Award of the Rotary Club, among others. May I request Professor Sovan Majumdar to take his stage and start his talk.
इसको नीचे कर देना थोड़ा। Thank you, Professor Naik, for your kind introduction. Good afternoon, everybody, for the first session, scientific session. And I am the opening batsman. Already the pitch has been set by an eloquent speaker, Professor Ani Hassan. So I'll be talking today on biophotonics for improved healthcare. Though you know that RRCAT is not known for its life sciences, but we do have a small biology group that is not biology, it is a biophotonics. It is a multidisciplinary group where we have physicists, biologists, chemists, engineers, and we do closely associate work with doctors. So with this thing, let me come to the talk. It is not working. So biophotonics activities at RRCAT, that is our group, has one of the important mandates is R&D on the use of optical spectroscopy and imaging for biomedical diagnosis. We use a variety of techniques based on fluorescence, diffuse reflectance, and Raman spectroscopy. Then imaging techniques like optical coherence tomography, which many of you know in the context of ophthalmology, and optical tweezers and micromanipulation. As you know, that Professor Arthur Askin got the Nobel Prize in Physics for the discovery of optical tweezers in 2018. So we work on intact tissues, cells, as well as body fluids. And our extensive work of our group has led to many deliverables, like this is oncodiagnoscope, early diagnosis of oral cancer. Then tuberculoscope, that is the detection of TB. This is a fluorescence microscope, very cost-effective fluorescence microscope. Then oncovision, and then Raman probe. You know that Raman spectroscopy, for performing Raman spectroscopy in field, you need probes. So that is this probe which we have developed. And all these techniques have been all these deliverables have been technology transferred to Indian industries, and it is now they are available in the market. So you don't need to, I will do. So the hypothesis is that optical spectroscopy and imaging can improve diagnosis and therefore treatment of pathologic conditions. So you shine light on the biological sample, and the light coming out, you analyze it with a detector and feed it to a computer for analysis. So the major attraction is Why we do that? Real-time, non-invasive detection with morphologic and biochemical information. That is the basic UPS of it. Now, there are three generic optical spectroscopy techniques, as you all know. So this is fluorescence, this is reflectance. You know that reflectance, this is a phenomenon of physics by virtue of which we are being able to see each other. Light falling on you, reaching my eye, I am seeing you as you are, and vice versa. But by looking at you, I cannot make out your biochemical composition. What are the cell, what are the chemical things which have made you up? So for that, I have to use different principles of physics based on either fluorescence or Raman scattering, which are inelastic scattering techniques. Now, this conventional spectroscopy, like you know that optical spectroscopy, you shine light onto a sample or biological thing, for example, tissue, and then you analyze the light back. But this light has a limited penetration depth inside a biological sample, because it is either it either gets scattered by the various cellular or subcellular organelles, or it gets absorbed by various absorbers sitting in there. So it has limited penetration depth. So light, in that limited penetration depth, in conventional optical spectroscopy, the light coming in, it is a volume integrated signal into that penetration volume. So you cannot get depth information from here, layer by layered information. Many a time, you know that biological tissues are layered. So if I want to have information from a particular layer, I cannot use this conventional optical spectroscopy. So for that, we have developed a variety of techniques based on several principles of physics. I will not go into the detail. Confocal, you are all familiar with confocal, either fluorescence or Raman. Then coherence getting, like you know that light has the property of coherence. So the coherent light you can get. But these two upper, this confocal works best for non-turbid samples, like transparent samples. But for turbid samples, it doesn't work well. This is applicable for turbid samples as well. But these techniques, you know that when I say turbid samples, water is not a turbid sample, it's a transparent sample. But when you pour milk in it, it becomes turbid. Turbid means it has wavelength-dependent absorption and scattering. Okay, so when you have this kind of sample, tissue is a turbid sample. So you have to use techniques based on source detector separation or polarization getting or time getting. So these are the techniques I am talking about. Now, we also do optical imaging. Okay, that optical imaging could be based on fluorescence or Raman. Hyperspectral imaging, you know that when you snap a photo, that photo gives you the intensity map. But by looking at that photo, you cannot make out the biochemical information. So for that, you need to marry spectroscopy, optical spectroscopy with imaging, and that is hyperspectral imaging. So we do that thing here, and we have developed various things here. And then optical coherence tomography. You know, everybody of you, it is called abbreviated as OCT, and it is layer by layer imaging of biological samples. Like, you know, ophthalmology, it has reached, and there are various OCT units and different ophthalmology centers in India. So here what it does is that there is a Michelson interferometer, and you have there are two arms, and in one arm you put the samples and another arm you put a mirror. So be it any imaging techniques, so you ultimately that goal is you have to have, you desire for high resolution, then structural as well as functional or biochemical information, non-invasive, it should be non-invasive in the context of biological samples, and suitable for clinical environment. So ultimately the goal is to reach to the clinic. Now there are several OCT based, we have done extensive studies on OCT, and we did develop real-time OCT setup. And with that thing, we have done several experiments on zebrafish and zebrafish bane. And we did one interesting experiment on the toxic effects of ethanol on zebrafish embryos with the help of this OCT, which we developed. Various variants of OCT we have developed. Now, that is on tissues or spectroscopic thing. Now, if we come to the cells or these biomedical diagnosis of body fluids also play a role in diagnosis, because whenever we are diseased, as Animam told, that blood test or urine test or any such test we do. Now, what we seek for, a change in concentration or composition of a particular biochemical constituent or analyte, for example, uric acid or blood urea or whatever it is. So which is an indicator of physiological or pathological condition. Now, normally these tests are done in clinical laboratories, but current clinical laboratory techniques, they have certain limitations, as we are all aware of. They require a series of sample preparation steps, which is time consuming. That's why you do not get pathology report instantly. Need multiple reagents, that is chemical intensive, and then they employ sophisticated, bulky, and expensive instruments, which are black boxes for them. So that requires specialized training. But ultimately, in the lab, the technicians do that. So use of Raman spectroscopy has been thought of, which has drawn considerable potential. And since it has the ability to detect disease markers in these body fluids at an early stage, because that Raman is molecular sensitive. So that leads to prompt diagnosis and thereby resulting in appropriate therapeutic treatment. Now, why Raman spectroscopy? The question is, because as I told that so as I told that this is molecular specific analytical technique, it is, and it provides molecular specific vibrational signatures. The molecules' vibrational signatures are manifested in their Raman fingerprints. Then spectra of sharp features allowing identification of the molecule by its spectrum. So there are several advantages of Raman spectroscopy, and it is being widely used by researchers to do this kind of jobs, apart from others. Now, challenges with conventional Raman spectroscopy and potential solutions. What are those challenges? So far, so good. But challenge is that Raman signals are usually very weak, and the complexity arises when you deal with biological samples. Normally, 1 in 10 to the power 7 photons is Raman scattered, and that you can imagine how feeble is the phenomena. Now, biological samples have very low Raman cross sections, so the situation is complex. And in body fluids, normally extremely low concentration of analytes present in body fluids. At the physiological concentration, their concentration is very less. So potential solutions, what? You have to enhance the signal level. So for that, you use surface enhanced Raman spectroscopy or drop coating deposition Raman spectroscopy, new variant of Raman spectroscopy. So what is surface enhanced Raman spectroscopy? Underlying principle of surface enhanced spectroscopy, what is that? It enhances the Raman signal. I will talk about this. It enhances signal amplification comes through the electromagnetic interaction of light with metals. So you have to use metal nanoparticles for enhancing the signal. And what happens, the physics happening here is a little bit I will talk, that you incident a light of wavelength lambda, it sets the electrons in oscillation, and a huge electric field is generated, and that electric field is responsible for enhancing the Raman signal. Okay, now, so this is the phenomena. So there are several hotspots created, and this signal, Raman signal, which normally was not, could not be detected, can be detected now. So how enhancement comes? So just a order of there's an example. So this is rhodamin 6G. We all know rhodamin 6G dye. So this is conventional rhodamin 6G with 25 micromolar concentration. You hardly can get any Raman signal. Okay, or Raman signal is very weak. Whereas if you use ACRS or surface enhanced Raman spectroscopy, you have orders of magnitude high Raman signal. So that is the advantage of ACRS. So this is just to exemplify the potential of ACRS. Now, another thing I told, drop coating deposition Raman spectroscopy, DCDRS. What happens, you know that all of we are familiar with the coffee ring effect. If you spill coffee onto the floor, then you see a pattern, particular pattern, tea or coffee. So this happens because of this. You know that these analytes or the solutes, they diffuse to the periphery. and make a ring after drying up. So this is used by this Raman community, and they have developed this drop coating deposition Raman spectroscopy technique. What happens, you know, that they drop cast a drop of analyte solution, and then they wait for it being dried up, and then they put the laser onto the periphery, and their concentration of the solute is much higher. So you get the Raman signal, which earlier was not could not be detected from solution. But though, despite their promising potential, they have this certain disadvantage. Applications of these things are not very suitable as on today, because they lack reproducibility and variability in the measured Raman intensity due to differential distribution of the surface hotspots which are formed, because you need to in all analytical things, you need to quantitatively determine the bioanalyte concentration. And for drop coating deposition, solubility of analyte with the solution, not all the surfaces you will get the Coffey-Ring effect. If you say, for example, very shiny surface, if you put the drop and makes it dry, then it will not have Coffey-Ring effect. So surface tension is a phenomenon of physics which plays a vital role here, and weightability of the surface. So I'm not going to the details of it. We have done lots of things here. So we recently proposed a nano trap enhanced Raman spectroscopy technique for enhancing Raman signal much higher than ACRS. So what happens here is that you put this, you combine these three things: optical trapping, and then DC DRS, that is dry coating deposition Raman spectroscopy, and surface enhanced Raman spectroscopy. So this is a new variant of Raman spectroscopy which we have proposed, and it got published in Analytical Chemistry. And one of my PhD students from IIT Indore, along with him, we did it. So what happens, you know, that you drop cast the solution and the laser is put at some point here, then this DC-DRS effect takes place. At the same time, the metal nanoparticles, you mix the metal nanoparticles along with the analytes. So metal nanoparticles get optically trapped at the focus part of the laser beam. And then after some time, you have much enhancement here of the signal. So this is what is happening. And we did, if you see that it has orders of magnitude higher Raman signal even than ACRS. So that is our thing. And it is all the drawbacks of ACRS, it could address to a large extent. Then we have done Raman spectroscopy on serological samples, that is SERA, during COVID, this lockdown, or during this COVID, first wave of COVID. We had been to ESIC hospital, Hyderabad, where they had BSL-3 labs, because BSL-3 lab is required for this kind of studies. So we don't have it here, neither in BRC, or that time it is not in DAE, I was told. And so we couldn't do it, any of our constituent units. So we did Raman spectroscopy, and we found significant differences between the COVID-affected patient's blood sera and normal blood sera. And another ACRS-based thing which we did, or which we have done, is that surface enhanced Raman spectroscopy based. Normally you did rapid antigen test, or RAT, but RAT suffers from the drawback of very sensitivity and specificity, because if the viral load is small, then you cannot do RAT fails. So to enhance the sensitivity of RAT, we have used ACRS, we have combined ACRS with immunoassay. Now, I will come to the cellular analysis, because intact tissues and body fluids now in cell. Disease and external perturbation lead to biochemical and biomechanical alteration in the cellular system. So physical characterization, that could be two types: biochemical, which is biomolecular composition, biomolecular abundance, biomolecular state, or biomechanical, which is membrane integrity of a cell, or cytoskeleton rigidity, or morphology. So we have developed various techniques, novel level-free, non-invasive tools for cellular characterization. So for biochemical, we use Raman and absorption spectroscopy, whereas with biomechanical, we use optical tweezers and quantitative phase microscopy. So all these things we do. Now I come to the optical tweezer, as I told you that Arthur Askin got Nobel Prize for discovering optical trapping. So what happens, that if you tightly focus a laser beam at the focal spot, you generate a gradient of this gradient force and gradient of radiation pressure. All of you are experiencing the force exerted by light onto you. That force, how can be taken to advantage? Professor Arthur Askin first showed that. So the thing is that it is a tool for manipulation of microscopic objects using optical tweezer, and that then only it is possible to study single cells. Okay. So what happens, that there are, just without going into details, when you shine light onto a material or in a body, there are two types of force. One, gradient force works, and another is scattering force. Scattering force, say for example, laser you are shining onto a object. That scattering force pushes the object along the beam of the light, whereas the gradient force tries to pull it back. So it is the tug of war between these two forces which is exploited in optical trapping. So what happens, that in optical trapping, this gradient force need to be more than the scattering force, obviously, because you have to balance the Newton's laws of motion. So Newton's this thing. So you need a laser light, and you have to focus it onto with the help of a high numerical aperture objective. Then it produces a force of the order of piconewton, 10 to the minus 12 Newton. And the particle gets pushed towards the highest intensity and trapped. This is how it happens. So any cell in the field of a laser, it gets trapped. So that is the thing. So applications, because you know that you can, once you trap a cell, that's why it is called optical tweezers. Without really touching the cell, you are basically using light to catch hold of a cell. So once you catch hold of a single cell of the order of 20, mammalian cell is of the order of 20 micron, as you all know. So then you can do various micro manipulation using laser lights. So you can have mechanical properties of cells like elasticity or intracellular forces you can measure. Also, it aids in spectroscopy of single cells for biochemical information. So Raman optical tweezers, that is the concept. We did develop Raman optical tweezers. So we have done several studies on optically controlled rotation, transport, and orientation, because when you develop certain technique or certain setup, then you play around with it, and in the process you learn many things. So this all happened in the learning phase of this. So we published several papers onto this. So let me tell you selected applications. I will just give you a glimpse. This is 3D rotation. Normally, in a microscope, when you see an object, you see the two-dimensional view of it. The other part of it, you do not see. So you have to rotate that object. So with the help of optical tweezer, rotate. 3D rotation is possible. So you see the other things. Similarly, one application I will obviously tell you that malaria diagnosis. So this is RBCs, okay. So normal RBCs in the field of laser or in optical tweezers, they have this kind of windmill type of movement, very rapid movement. But if the RBC is from any malaria affected patient, not even they are individually get affected, so the rotation speed is much slower. So this is what is normal RBC and malaria-infected RBC. So this particular phenomenon was very interesting, and Professor Arthur Askin, in his Nobel lecture, he mentioned about these things. He told verbatim that I was told by my colleagues that one Indian group has developed this optical tweezer-based malaria diagnosis. And when I say Indian group, it is not American Indian, it is Indian, he told in his Nobel lecture. You can hear his Nobel lecture in the YouTube, okay? So this is one of the things. And we have done optically controlled transport. Various things are possible with the help of optical tweezer, because it is a very powerful tool to do basic biology as well as physics, okay? So it is Alodia densha, this plant cell, and this is optical gun we have, and we have also US patent on that. Now, as I told you, that optical tweezers, with the help of optical tweezers, catch hold of a cell. Now, you have to do you have to derive molecular information or biochemical information. So you have to combine these optical tweezers with Raman spectroscopy. So we did that thing, and that results in Raman optical tweezers, it is called. And selected applications we have done with non-resonant Raman spectroscopy coupled with optical tweezers. So we did work on several such things, even on effects of mobile phone emission on human red blood cells, and effects of acute different stress conditions, how RBCs change. That is the essence of it. And then resonant Raman spectroscopy have done simultaneous photoreduction and Raman spectroscopy of red blood cells to investigate the effects of, that organophosphates, that pesticide, how pesticides affect. So all these things are possible on single cell basis, on a single cell level using optical tweezers, Raman optical tweezers. So you are aware of absorption spectroscopy. We all do absorption spectroscopy there. So single cell absorption spectroscopy, that instrument cannot do. So with the help of optical tweezers, you can do single cell absorption spectroscopy, which is a very, very new concept. Okay, so we have developed this technique here, and we are going through various experiments now. So for example, this is just to give you an idea, absorption spectra obtained from single RBCs. Okay, so spectra, SORAD band and oxy and deoxy, you can clearly see here. So you can see any cells are possible. So this is just to show you. Then another thing is diffraction phase microscopy. That gives you a fluctuation map. How cells, that cells fluctuate, that cell membranes fluctuate. So how to map it dynamically? It is not possible using any other technique. So you have to use diffraction phase microscopy. And on a single cell basis, you have to couple optical tweezer diffraction phase microscopy. So application is you can measure 3D thickness maps of cells in a level-free, non-invasive manner, which is not possible otherwise. Morphological parameters like volumes, surface area, sphericity index, etc. of a single cell. Thickness fluctuations sheds light on the mechanical properties of membrane. So if it is rigid, then fluctuation will be less. Similarly, identify attached cells, intracellular viscosity, rigidity, etc. I have listed a few, but many applications possible which you can think of. So there is no limit. Then another concept which we are thinking and which is gaining momentum is that multi-dimensional approach. You combine diffraction phase microscopy, Raman spectroscopy coupled with optical tweezers. So all the things together. So advantage is that from phase, you get the change in shape of a cell. Whereas with Raman spectroscopy, you get the biochemical information. So all the things are in a single shot. So this is possible, and it is to understand at the basic cellular level, everything. Now I come to the second important mandate of our group, that is phototherapy. We have photodynamic therapy of tumor. You may be aware of photodynamic therapy of tumor. You know that you are aware of two forms of therapy, radiotherapy and chemotherapy. Radiotherapy is a bulldozer. It kills everything on its way, both normal and abnormal cells. Whereas chemotherapy, there you inject a chemo drug, which is preferentially accumulated in the rapidly dividing cells. And since cancer cells are rapidly dividing, tumor cells are rapidly dividing, they sit in there and they inhibit the cancer growth. All life science people here sitting, they know. But it has a side effect, not only one side effect that you have skin darkening or hair loss, but the most severe side effect is cardiotoxicity. All chemo drugs, if I'm wrong, please correct me, Animam. So all these chemo drugs are cardiotoxic. So you will find that patients who are on chemotherapy, cancer patients, they die of not cancer, but they die of heart attack. Okay, so that is the thing. So that is why the photodynamic therapy of tumor, here you use a drug, I will tell you, and you light, also light. Unlike chemotherapy, the drug is inert till the point in time you shine light of appropriate wavelength. Okay. So, and since it is the same property as chemo drug, it accumulates in the rapidly dividing cells. So the cells get killed because of phenomena I will tell you. Then another, this thing is spin-off of this thing, antimicrobial photodynamic therapy and antiviral photodynamic therapy. By the same token, the tumor cells or cancerous cells, they retain this drug. So bacteria also retain this drug. So you shine light, then bacteria get killed. Normally, it is very important because recently it is gaining attention because you know that multi-drug resistance, you are hearing this thing that you, for an infection, you register antibiotic. That antibiotic ultimately develops resistance. You know that it is just like a terrorist group. Terrorist group is there, and the government is finding ways to curb that terrorism. But the terrorists are very clever. They adjust their ways and they understand the strategy government is taking. So after some time, the same strategy will not work. So after some time, the same antibiotic will not work, you have seen. And we are heading towards the era of antibiotic resistance. So 5 years down the road, if we continue like this, you will not find a single antibiotic which can kill which can cure a simple infection on your finger. So that's why this antimicrobial photodynamic therapy is gaining attention. It is just like surgical strike. So the terrorists do not know where from the strike is coming, and they cannot adjust themselves. Okay. So antiviral, again, recently, in the recent years, we have, during COVID, we have learned these things, and a lot of papers are coming now. So this is photodynamic therapy. I told you that photosensitizer, this is selectively retained by the rapidly dividing cells. Then you shine light until the point in time you shine light, it is inactive. And when you shine light, it generates that drug sitting in there. It reacts with the surrounding oxygen, and in the process, oxygen gets excited and produces singlet oxygen, other superoxide radicals, which are toxic to the tissue. And since the host tissue is a tumor, the tumors get killed. So this is the thing. Now we have done several experiments on animal models. So and we synthesized one photosensitizer. This is a chlorophyll derivative called chlorine P6, and he's had high triplet yield because you know that triplet state is from where these things happen, and absorption in the red or far infrared region, because that is the region where tissue you have higher penetration depth. There is nothing which can absorb. So before photodynamic therapy, this is the tumor induced in an animal in albino rabbit, and then hamster cheek, and then 1 week after PDT, and then 1 month after PDT, the tumor has completely gone. So this is the result of this thing. And we have, recently we have developed one copper oxide, this copper iodide complex of chlorine P6 for X-ray activated PDT. And one Indian patent has been granted for that. Now, antimicrobial photodynamic therapy, I have already explained, and we have done lots of things on these cells, several bacteria. And mammalian cells also, we have, in mammalian cells, we are now bacteria infected. In vivo, we are doing experiments. Now, antimicrobial PDT and wound healing studies. We have done lots of studies on wound healing using PDT. Okay. So there are lots of bacteria there, and particularly it is important in diabetic ulcer or diabetic wound, where the normal antibiotics do not heal up. Now, this photodynamic research in RRCAT in our group, it has led to the development of handheld APDT device with organ-specific attachment devices for infection treatment. So this we have done, and this has been possible due to the public-private partnership. That is, you know that all DE centers now have incubation centers. So earlier only technology transfer was there. Now it is through incubation center. So we have done it with the help of a collaborative initiative with Dr. Kieran Care, a company based on Delhi. So they have come up with this kind of photo disinfection device for wound infection treatment, and also acne treatment. Most of the acne are bacteria because of bacteria. Similarly, we have intranasal photo disinfection device. This is the device. These devices we will find very soon in the market, maybe within 2-3 months. So they are launching this market, these devices through different routes like Amazon. So they're like just like any other items, you will get these things in the market. So we have now in vitro validation we have done, and in vivo validation on limited samples we are doing. So we have to do more such in vivo validation before it is there in the market. Then another thing is that UVC mediated phototherapy. That everybody of you know that disinfection of the DNA. If you shine on UV light, then mutation of genes takes place, and that lead to the death of microorganisms. So we can do it antiviral and antibacterial. So with the UV light at around 254 nanometer, that is the UVC, you can do both these things. And this particular principle has led to Neil Hashmi, one of these instruments which we developed during COVID time. And this Hashmi is developed in collaboration with Research India, Bhopal, during lockdown, during that first lockdown period. And this particular device is in all the centers, including BRC, all the centers of DA, as well as in Indore airport. It is being extensively used for disinfection. It is a wide area disinfection device. It has 4 arms. If you recall, during lockdown or during COVID first attack, there were a lot of UVC devices mushrooming in the market. So we thought that why not we do a principal study here, because the dose which is important, that was not there in the dose, you were not receiving any of these devices. So we did a theoretical calculations and we developed these things. It has 4 arms, flexible 4 arms. It can be like this, it can go like this. So you can do disinfection of any area, whether it is slanted area or plain area like that. And it is, this is one of the highest number of technology transfers has happened with this device in BRC, BRC, that think ETCD. Maybe around 12, I think, technology transfer has happened after this what is called tele-ECG of DAE. So another field which we just touch upon, that is optogenetics, where we are working. That is, you convert the photo unresponsive cell to photoresponsive specific purpose. So we are doing these things through this optogenetic vector, and then we are transfecting the thing into mammalian cells, and we are getting this kind of photoresponsive thing. So this optogenetics we are doing. So now that is the end of my talk. Because of time restrictions and to give you an overview of all these things, I touched upon all the things which we do, but that is the purpose, because you come to know about what we do, and then we can have collaborative things, and we are very much open for collaboration, because our group is a multidisciplinary group, and you can, if you can think of any fundamental biology problem or any biology problem where you need this kind of techniques or devices, then we can collaborate. And because many times we do not know each other, and that's why we cannot think that any of these experiments can be possible. We think that kash aisa hota to main aisa kar leta. So that is the thing. So before I finish, I acknowledge the what I presented is the work of all my group members. Okay, Laser Biomedical Applications Division. Then colleagues from other divisions as well, they have contributed. Then I would particularly thank Dr. Pankaj Chaturvedi and his team from TMH, because they are our collaborators. Then doctors from, as I told you, that we closely work with doctors. So doctors from MGM Medical College Indore and Chaitram Hospital Research Center Indore, because without doctors we cannot go, we cannot do anything. Then IIT Indore, Professor Sharad Gupta, and last but not least, Dr. S.V. Nakhe, our director at RCAT, who always has taken keen interest in biophotonics related research. And but for him, this team meeting is possible. Thank you. Any questions I will take?
Yes, thank you, Soen, for a nice presentation and bringing out various activities in your group. Instrument development, as well as research work, as well as photodynamic therapies. Now, the talk is open for discussions. Any queries? Please. Somebody can take a mic also.
Mic ले जाओ ना.
Just a minute.
Just a minute for this.
Yes. Because we are online, or I think unless until you speak on a mic, online persons will not able to hear anything.
अंदर जाके लिया.
What? Yes, you can restart your question.
Please.
Yeah, it's a great talk. Thank you. So I'm just so for this optical tweezer. So when you are doing this single cell, so is it possible to actually do a little bit of the high throughput way? For example, 100 cells I want to know, and then if there's a property, because there's a distribution of the property.
Yes, yes, that is possible. Then what we do, I have talked about, I have not gone into details of optical trapping. So it is possible to set up multiple traps, multiple optical traps. So you have through techniques, okay? So that is called holographic optical tweezer. So we do that, and so you generate multiple traps, and then you can trap simultaneously many cells at a time, so that you can have large yield of the things. Yes, it is possible.
Thanks.
Yes.
Yes.
Thank you, sir, for the nice talk. So my question is from your ACRS part.
Yeah.
You talked about these gold nanoparticles. Can you comment on the size of them? Is there a barrier?
So yes, that is a nice question, because you know that many a time you will find in literature that there is no systematic study on the size of gold nanoparticles. Whatever size are available in the market, they use it. But so we synthesize our own gold nanoparticles, and we have addressed to this problem that which sized gold nanoparticle will be optimum for a given problem at hand. Okay, there is no unique size. Okay, so say for example, you start from around 20 nanometer, because it is a distribution. 20 nanometer is the peak, and you have plus minus 5 or 10. Okay, so 20 nanometer, 200 nanometer we have studied, and we have seen that for different techniques, the size varies from, say for example, 40 to 70 nanometer. In this size, they are optimum. So there is no one size all nanoparticle. Yes.
Yes. Come here.
Slightly related to the first question again, but in the context of measuring fluctuation of cell membranes, again, can you do an ensemble measurement and give us a distribution?
Yes, it is possible. Yes,
Okay.
it is possible.
And the second part is that what is the resolution of the fluctuations that you are measuring?
That is submicron level.
Submicron level.
Yes.
And the last one is when you are doing these measurements, were these cells like they were synchronized or they were a mixed population?
Synchronized means you are saying that mixed population of cells?
Yeah, like the cell cycle was synchronized or mixed, because there will be some dividing.
See, that you can always plan for your experiment. So what we have done is, I mean, there are several experiments we do, but this particular thing was not done, for example. So at any phase of the cell, you can take that cell out and do that. It is possible. I will talk. Yes, ma'am.
Did you try to look at sickle cell because you have the ability to look at RBCs individually?
Yes.
So sickle cell carriers and all, because that's the need of the day for tribal populations.
Yes.
If we go out and do anything and it's not done at point of care, then we do not get back the same population.
Exactly.
So do you think it could be used to pick up carriers or individuals like that for sickle cell? Because it will just be a RBC, red blood
Yes,
cell.
yes, sickle cells, we have done some preliminary experiments, but the kind of experiments you are telling, for that we need to have that kind of sickle cell supply, that otherwise, and a doctor's involvement who is interested in sickle
The
cell.
government of India has given a large population study for tribals to Mysore and Orissa.
Okay.
So if you want, we can
Sure,
get
we
connected.
will.
And the next one, which is a money-making one, is for assisted reproductive technique, your optical tweezers
Yeah.
for doing pre-implantation genetics.
In vitro fertilization.
Yeah, before when we do IVF, we do PGD, pre-implantation genetic testing. And that's when we do that micro dissection of the morula. And while doing it, we sometimes damage the morula. So with optical tweezers, would it be safer for the remaining cells?
Yes, it is. It is. We have thought about this kind of problems, but let me tell you honestly, here in our center or any DA center, whenever we, it is true for all the researchers, any of the in any field, that when you think about any this kind of problem, here particularly, you need to have a close collaboration with the doctor, and the doctor should be interested in the problem which you are thinking. So that kind of synchronization is required first. So that minute, I'm sorry to say that is lacking. So that's why this kind of problem, though very fascinating problems, but that cannot be materialized in practice. That is the thing. So as you are saying that this is possible, then we will think. No, there is no such thing.
Kamini has a fertility center, and we could give the embryos which we are discarding after consent, ethical consent. Once the family has their baby, we discard the remaining.
Okay.
There's a rule that you have to keep it for X number of years and all that. So those samples we could give, and then subsequent this could be a routine technology for instead of putting in embryos which are damaged.
Sure.
So now what we do is we put 3 embryos, and then people get triplets. If we knew that embryo was good, we could put only 1.
Right. Thank you. Will do. Yes.
A very nice and exciting talk. I will discuss with you later. I will not take too much time. Just because you have given the overview, which I really like. In disease biology, including cancers and infection, you have shown the effect of lights and these things. So radiation, one paper was that effect of radiation on cancer. So is it that a protective role or a kind of promoting role for cancer?
It is a promotive role, because you just know that you if you say, for example, cell phone radiation, it though we have not done on cancer cells, it is just on red blood cells, because those are the cells which will be affected first. So whatever this limited data show that this is reversible, so we should not be panicking too much on cell phone thing. That is what our hypothesis is, but it needs to be ratified by very many experiments on different cells.
So your preliminary data show that it is not dangerous, right?
No, it is not dangerous. That is what limited data. Again, I caution.
So new generation kids will be happy with you then. Thank you.
Yeah, that is there.
Yes, thanks. We will not take more questions because of limitation of time. Thanks, Owen, again.
Thank you.
Let us clap him. Next speaker is in this session is
Sir, now I have a request. I would like to request you to please present a memento to Professor S.K. Majumdar.
Yes, we'll move on to the next talk. Next talk is by Dr. Abhijit De from ACTREC TMC, Navi Mumbai. He is engaged in multidisciplinary research involving preclinical molecular imaging for understanding the breast cancer biology, testing, experimental therapeutics, and cancer nanomedicines. He has been awarded with the ICMR International Fellow Senior Scientist Award in 2015. He has 110 research publications, reviews, book chapter, editorials, 10 patents as required by him, and three patents has been granted. He is a member of the editor boards, scientific reports, NPG, breast cancer, Doe Press, American Journal of Nuclear Medicines and Molecular Imaging, and frontiers in molecular diagnostics. He has a life membership of Indian Society of Cell Biology, Indian Association of Cancer Research, IACR, Indian Society of Nanomedicines. Dr. Abhijit Dev, please take a dais and you can start your talk.
Thank you, sir. While the slides come up, I also like to take the time to thank the host, Institute RRCat, the organizing team led by Professor Majumdar, Ajit Upadhyay, and all. And it's really in a short time such a beautiful hospitality arrangement. It's really pleasing and unbelievable thing for many of us. So big congratulations and thank you again for having us here. No problem, I will stand here and. Okay, so on the all of us are here to has come here to learn and from each other's perspective, and definitely this is a perfect session that started by Professor Majumdar's talk, introducing you with the concept of optical imaging on many perspectives, and what is a vast area that it is being covered, and hopefully my talk will add some more dimensions that optical imaging can also offer you to solve problems in the biology sector. So this is our campus. In the monsoon, post-monsoon, just like RRCat, it is also very green at this point. But there are a lot more big buildings coming up, so we are a little messy condition than RRCat right now. So just because it was meant for interaction, so I just put this up that I may not have time to talk about all the things that my group is involved in doing and contributing in research perspective. But this is the whole sole summary of my conducts. I have also joined ACTREC in 2009, and there is a in the field of cancer, because the disease is systemic and often it is across the tissue barrier, we need to see what the disease is doing inside a body. So this is where the whole body imaging comes to play role. And our campus actually took the initiative to start whole body imaging diagnostics for development. So it can span right from very high energy probes like positron emitters, which is through the PET scan, to all the way on the ultrasound, which is the very low energy source, but very safe modality. So optical imaging comes in the spectra of light, as we all understand, and most of it that I would be covering now is dealing with the section of light that our eyes can perceive. So it's primarily in the range of 400 to 800 nanometer range. So thinking about utilizing these sort of photonic signal as a imaging diagnostic and how we solve different issues in the biology of the healthcare per se, how we can resolve them. So that is the purpose, and that is where this facility I brought up, and it's up and running for last 8 years. It's one of the one of the most active, this is my pride, that this is one of the most active center in the country right now. So, if I have to theme my wholesale activity in my lab, then this top part is says what I do. I am in the orange box as a biologist. I talk about molecules. I talk about validation of those functions. They are functions in the cell context or in the physiological context in small patients like mouse models. And with an expectation that all the knowledge that I'm generating would make some effect at some point of time in the clinic. So with that goal, let me tell you the problem, the statement of the problem is it's a daunting task, I believe, that resolving macromolecules at work. And why it is so, you can very easily predict just from this slide that the resolution of the size. So the macromolecules which are of nanometer or Armstrong scale, and if you have to resolve their all the things that they are performing in a tissue scale or in a cell, which is like log, 1 log to couple of log folds bigger situation, where there are lots of molecules in that area. So the performance is really a daunting task. But over the period of time of last 25 years, this field of molecular imaging has been contributing. I think we have made fascinating progress in resolving what molecules do in the context of physiology. So with that goal, I just want to highlight a little more. You already got a very good background from the previous talk, that the optical imaging. So there are primarily my talk will be focusing on protein based, and as I said, it would be the light that we perceive through our eye. So where there are a couple of photon emitters, like either luciferase or it could be chemiluminescent molecules as well. So luminescence as well as fluorescence. So where in luminescence case, you do not have to do anything. It's come out of dark, so it gives the best resolution possible because it is the photonic signal coming out of the dark. Versus in the fluorescence, the challenge is you have to shine with the light and you have to spectrally resolve the emission light that is the sense. So there are, but the platter is actually, no system is perfect. And where the fluorescence that is being the challenge, the advantage is we have the platter is very big. The number of chemical dyes that can be synthesized, different forms like particles like quantum dot crystals, various other nanoparticles, organic dyes, and then there are fluorescent proteins. And again, there is very big platter of fluorescent protein available, which you can use for multiplexing, so that because in the cell system or a physiologic system, molecules do not work isolated, they work in a together manner. So there is the field demands that we have better capability of multiplexed imaging, and we can simultaneously monitor multiple molecules at work. There, the luminescence-based area is relatively limited options. We have few options, but their greatest advantage, as I have already said, the signal to background ratio is super high, and therefore the resolution is super high. So focusing more towards now with the reporter system, which is what as biologists we deal with primarily. So this is where this fluorescent reporter proteins, and we have the red fluorescent protein, which was now mutated and formed into a spectra, a platter of spectra it was back-shifted to the green area called M citrine, to banana and all the fruity variants, and these are all commercial. And this is actually the work of Roger Chen, who is the winner of Nobel Prize Chemistry in 2008. So, and these clonal variants, so they are the original protein, which is isolated from coral. It is actually a tetramer, which is a problem. But then he has mutated them in a way that most of them are monomeric, and they are fast maturation, and there is a more so the spectral pattern is available, so you can use each of them to color separate and tag your molecules of interest at the work. On the other hand, in the bioluminescence reporter, the field is primarily go with this reporter called Firefly or the brittle luciferase, which has this unique substrate called which it catabolizes to produce the photon, and which is D-luciferin. And there are lots of variations available in the marine area, where there are lots of biological entities they carry for either their reproductive behavior or for catching prey. They have luciferase systems they use, particularly the deep sea ocean animals. And the problem is it also unique, this class of reporters, even though they are different enzymes that are sequentially, they are unique, but they all utilize the substrate called cilantrazine to produce the light. So in that sense, even though we have variable genes, but the substrate is the only non-cross-reacting substrate with this is the cilantrazine. So essentially, for the last 30 years in the biological community, as we know, that we are stuck with a system, assay system, very common assay, a lot of us have used, is dual luciferase assay. So this dual luciferase, we have basically remained with no choice other than one Firefly luciferase and one Renilla luciferase and two of their substrates. But now there is a new project. We are working on this with a group of Russia, team in Russia. So this is, there is a set of fungus, the mushrooms. Even in Indian varieties, we have now identified now and got published. So these varieties are very unique. And this is a new set of gene, evolutionary, completely divergent, and their substrate is also unique. So this is where we have been working, and this is one aspect we just wanted to touch upon through this just one slide. That I'm just showing that in contrast to the other known luciferase commercially available, and this is the new mushroom luciferase, which is non-cross-reacting. We are testing the 4 genes and 4 substrates. Furimazine is a commercial substrate for nanoloop, which is the smallest luciferase being the brightest. And you can see in that comparison, these are much weaker, but they are completely non-cross-reacting. So, irrespective of its weakness, it is still good enough. Means this is super bright. Actually, it saturates the camera. The kind of imager we have today, it can saturate the camera very quickly. So, but in that context, the Firefly is still the winner, the most commonly used. But luz we have tested, even this is the cells implanted in the lung to understand whether we can resolve this weak luminescence. It can penetrate through the tissue and we can still resolve. Okay, so the most common aspect that this field of systemic luminescence-based imaging and its application that it covers, it has been listed here. So there are, starting from different tumor, understanding tumor growth kinetics, whether it is in the short form or long form, long-term non-invasive, because these are non-invasive toolbox. So you day in, day out, you can bring your patient, that is the mouse, or the rat model, anesthetize, get them scanned, put them back in their normal physiology. So it gives it has added an extraordinary value in understanding and evaluating disease in many perspectives, starting from the disease spread in the area of cancer. Beyond cancer also, there are a lot of applications. I'm in the ACTREX, so I'm focusing on what we do. Determine efficacy of therapy interventions, their follow-up, even the relapse scenario, post-therapy. Then there are also the testing novel diagnostic probes such as probe distribution, uptake, etc., etc. So, and it's not just can be done. There are further, the disease spread from the primary. This is the primary, this is the mouse. Because this is such a strong signal, there are small signals which are now masked. So if you cover this area and then you get to see there are new other micrometes that has been forming in the on the go. So, and then you can also cross-validate after dissecting on the final, once your subjects you can sacrifice. Another area last about 10 years, we have been working in close collaboration with IIT teams, Professor Rohit Srivastav's team in BSB. So this is where we use these nanomedicine area. We have been using gold-based and organic dye-based photothermal agent. So Professor Majumdar's talk, you heard about the photodynamic therapy. And here, the materials can be designed so that upon a photonic trigger, they actually oscillate and generate the heat. And this heat can actually, you can imagine when we get high fever. So what we try to do is put a wet band so that what is to do that is to save our brain cells from that hot blood to get supplied. So cool it down, cool it down. So because the heat actually destroys the cells, and irrespective of whether it is cancer cell or whether it is normal cell or any other type, it's a physical therapy. So we can generate these kind of nanosphere particles where actually either liposome or polymeric, we have actually many products made. And in spite of spending my time here, I will refer you to the, we have a separate poster, poster number, I think 33. So I refer there. So just briefly, so the material can be directly injected, and then it's an incident of 5 minutes of very safe low dose laser, which is 650 milliwatt, which we have tested for safety without the particle on the live mouse. And then when it is intermixed, when both the material and the laser is on the spot, no matter whether it is the tumor or the cell, it will burn and it will destroy the tumor. And we have been seeing this. So what you get is, so this is like live monitoring over the period of, so this is the control group versus the treatment group. And when we do the treatment here, after well-grown tumor developed on the mouse mammary fat pad, and then we injected the material and treated with the laser, and you see that this is the ATP. The firefly luciferase, the cofactor is the ATP. So the luciferase signal do not produce if the cells are dead. So it indicates that essentially the live cells present. So pre and post therapy, you can see we have done a couple of treatments, and it has this tumor mass is substantially shrink. And what it has caused is actually able to lengthen the life. And this is something that every doctor in the cancer hospital looks for, that what is the survival advantage. And we are not talking in no uncertain term. We are not talking about days or weeks of survival advantage. We are talking about doubling the life, so life expectancy. You can see the mouse which otherwise die within 35 days. now can survive at least up to 70, 80 days, even longer in some case that other models that we have performed. So more details we will discuss more in the and my student will discuss in the poster session. So moving on, the talk that I want to focus is catching the molecular information in the live context. And this is where another assay that we have developed using again the reporters, optical reporters, is the donor acceptor based, like FRET, a lot of you know of fluorescence resonance energy transfer, where it follows this Jablonski diagram of transferring energy, resonant transfer of energy from the acceptor to the donor. Here, in our case, we use in the braid, we use the bioluminescent donor. So the advantage here is I am not signing any light. So I am taking that advantage in this assay, where I will add the substrate, it will produce the light, but then it will within the proximity of that same range as FRET works. So the braid also works in the same range. Within that proximity, the resonant energy can actually trigger this fluorescent moiety, and you get the affected signal of that characteristic fluorescent property, light emission. So this beautiful system we have adopted for our in vivo imaging, and that way this has challenged. This is on a challenging the task of biochemists of understanding proteins interaction. Because no protein, oftentimes proteins actually work in coherence by interacting with other proteins. So understanding protein-protein interaction is a very important aspect, and this is where this assay has worked fantastically. So this is just old data from published work. So this is just in one form that the proteins of mTOR pathway two domains we have attached with the donor and the acceptor, and when they interact through their proximity achievement, this affected signal of the characteristic turbofluorescence we can see. And this actually has teached one assay that you can perform to run your lysate-based assessment. You can perform in the cell-based assessment in a live cell format, so that you can also perform screening that can either promote or inhibit this interaction. And then you can also perform in the live mouse. So this is bit past. We have many applications on that area, and it has well proven and well taken. So after coming here and developing, having our capacity of optical imaging, so we started thinking, can we do more? So dil mange more, right? So we thought that if we talk about cancer early detection, so what is how it is possible? Why it is not being able to be successful so far, even though the war against cancer was declared so many 15 years back. So the issue is that what the engineering ability can actually give us the power, can we resolve the earliest event? So what is an earliest event in a cancer cell? The cancer cell, the proteins, the nucleic acid, the translate into the protein, and the protein, if there is a change in the nucleic acid, then the protein is altered. And because it's altered, its function is altered, and that's the beginning. And this is where the phosphorylation, so the activation of the protein. There are a lot of kinase activity, there are a lot of protein get activated, then that signal get transferred, the whole signaling cascade changes. So these are all well known in the biology of cancer. So if we have to really dissect it out, so phosphorylation could be, or any other form of activation of protein is one of the early events. So can we detect that fast change that is happening? And that's where we thought, can we push our braid sensing, braid-based sensing for protein phosphorylation activation? And this is where we this challenge of developing a sensor on STAT3 because it is such a big oncogenic. It is in the center place where once it is get activated by either growth factors, cytokines, kind of ligands on the surface, then once it is phosphorylated, it is actually a dimer, and then it goes to the cell nucleus and then drive the transcriptions for many genes, which are oncogenic. And there is more so, sir, I'm running out of my time. 5 minutes, okay. So more so, there are two main sites. So although the STAT has been actually, primarily there is a canonical activation, which is the tyrosine at Y705 position. But there are also a active phosphorylation site, which is setting at 727. Now, this we have understood from the clinic when we analyze the samples of TNBC breast cancer. Actually, the panel of breast cancer cells we analyzed for these three different, so immunohistochemistry were performed. And you can see that the total protein is present very much in the cancer patient samples. These are neoadjuvant chemotherapy trial patient samples. So a good number of patients were analyzed, and we saw that the total protein is present, but the canonical is not there, and it is mostly negative for that canonical. So we were really surprised, and this data actually puzzled us for quite some time that what really happened. STAT is there, but it is not on, but it is still tumor. So then we actually thought that, well, we'll just try with the other activation marks, the antibodies. And there we see that the very nice correlation that at least in the TNBC group, that when the total is present, it is also high presence for the sedin mark. So it is actually operating through the non-canonical mark, while most of the scientists are actually considering the tyrosine as a marker. And there are inhibitors developed for that and all that. So I will quickly move through now. So this, we quickly set out the assay, so similar way that donor and the acceptor proteins. Initially, we have to actually screen through by different combinations. So that is what we did. And what I find is that 3 + 4, when we combine this, the N-terminal fusions, so that's where the change in the plate signal happens in the presence of the trigger. So this is just to test that which would be my sensor. And once we select this as a sensor, then we use that. There are many complex, very complex experiment. I will not have the time to explain you. But what we did is we made a whole panel of mutations, and with single mutation and double mutation for Y705 and S727. And you can just focus on these three, clone 5, clone 7, or clone 8, where these two marks are at least nil. And you can see for two different cell types, in both cases, the very similar result, that it decreases a lot. And it prevents the dimerization, which is detected through our breast sensor. So then we thought that we will now use this platform as a screening tool. And we actually, this is where we are demonstrating that it is like a it is a 384 well plate format. So it's a very 1,000 cells per well can be accommodated. And we can resolve this kind of signal using our optical imaging toolbox, and we can run as a high throughput screening. So we have tested for quite a few inhibitors, of which you can see the static. Where is static? Static is here. So this is the Y705 inhibitor that was designed before, commercially available. And in comparison to that, there are many new inhibitors like niclosamide, which is an anti-Helminth drug. We are very excited about this drug now because this is a very cheap medicine, and it's a FDA-approved medicine already in use for tapeworm removal. It works through multiple network, but it's one of the hit target is STAT. And what I'm showing you here by comparing the static versus the niclosamide is that it can actually inhibit both forms versus static is very specific for Y705 inhibition. So, it affects the dimerization, but it also affects the niclosamide actually minimizes the dimerization, dimer formation much more. And it is, in turn, it also affects the cell survival. So we are very excited. So this is the last piece of data probably I will share and then I'll try to stop, is that, then this drug, it is already a over-the-counter medicine, so it may not be a very attractive for an oncology pharmacy company. So thinking these kind of things, but you can, if you can chemically tweak this molecule, then perhaps you can develop a new patent and then that can be actually commercialized. So thinking that, so this is the work that was done. We have actually, every nucleosamide was actually at, if you go to the next slide, you can see that this is the chemistry that was run. And when this HA conjugate of NSA was formed, they can self-assemble, and this is the TAME image. And this drug was tested alongside the niclosamide alone, and we see slightly better or almost near similar effect in the in vivo. So it's a good product that can be done, and it is more receptor targeted. So this is HA is hyaluronic acid. It can sense the CD44 receptor target, which is also a breast cancer stem cell receptor. So that way we can actually have more targeted therapy. Parallel to the STAT, we are excited and we are demonstrating that there are multiple more such phosphorylation sensors were developed for measurement of cell functions. So in collaboration with Peter Ray's group, where in the ovarian biology, so the ARC sensing, ARC sensor was developed based on BRAID, which only when it formed a conformational change by the substrate and the domain interaction. So then this transfer of energy happens and you get to see. There is another one that is the AKT phosphorylation sensor. So AKT's migration to the membrane is very important in the biology of activation. So this is where we have attached the pH AKT domain with the N loop, and the membrane protein is targeted. There is a turbo, my acceptor protein is actually on the tagged on the membrane surface. So when the AKT actually migrates there, so the because of the proximity achieved, so then that energy transfer, and this could be a good sensor for AKT activation in vivo, and we have proved that as well. So with that, means I do not have to summarize probably. I can skip this slide, and so there are, I think there are molecular sensing, molecular functions is very important, and optical imaging has given us sufficiently sufficient ability in the form of screening it in a live cell that is in your plate format, or even in the in vivo scenario in a non-invasive format. So it is possible, and it is a great tool for many disease area where screening of activator inhibitors actions you can measure through very. And with that, I just want to take just 10 seconds to thank all the collaborators. I learn every day from them. And my group, which is Molecular Functional Imaging Group, the enthusiastic students, all their involvements and their hard work. And this is what we have solved many issues in the biology, and hopefully will continue to contribute more in this direction in the future. Thank you very much. And I'll be happy to take any questions.
Thanks, Abhijit, for nicely presenting your work and interesting work in cell biology in cancer treatment and other things. Now talk is open for discussion. May I request someone to take mic, please?
Yeah. Yes. Yeah. Um, that I am not in a position to tell you that. Perhaps Prasanna, can you help me on this matter? It is interaction meeting, so I think the A727, how it get phosphorylated. So it is serine. So can it be? Am I right? Right. So. Right. Yes, so there are multiple triggers, so either growth factor or the cytokines. So probably we have to understand these little further, but I think we have some data. The way we understand is EGF controls has more control to the serine part. And probably that is where in the TNBC cells we are seeing this particular activation is dominating and running independent of Y7O activation. Y705 is actually triggered by the cytokine dominantly, IL-6.
So that kinase is not known. It will be very interesting if you find out the kinase, then it will be easy to. That can be a therapeutic tool, right?
The kinase, I mean, the STAT is recruited on the receptor kinase, then it get activated there.
Yeah.
And once it is activated, we are catching that signal as a primary signal before it forms the dimer. And that's where our focus was, that once it forms the dimer, it changes the cellular context.
Yeah, then the pathway will be same.
Yeah, so that is what we focused more. And so can we catch that earliest event, which is the dimer formation, which is right after the phosphorylation, whether it is on that, or there could be other acetylation signatures and many other ways the proteins could be activated. So some of that we haven't been able to solve, but at least these two biology we have solved, and this is what we have understood right now.
And also the dimerization is similar, means by same interface.
Yeah, once it is phosphorylated, it is forming the dimer, and there is
interface for dimer is same.
Again, we can do little more thorough study by modeling there, which we haven't so far. But there possibly, as of now, I don't see any difference just based on our assay, but we haven't done any modeling.
Thank you.
That's something we can explore.
Do you have time for a question? Mine is a very quick question. So, in your bread pair, how big is the luciferase that you are attaching, or whatever the luminescent protein that you are attaching? My question is regarding, can it be used for a single molecule FRET, where the distance between, for a small molecule, the FRET pair connecting is a big issue, and you have a lot of technical difficulties in there.
Right. So FRET-based sensors, so it could be either using fluorescent protein, and then it is the same case as BRAID, because in BRAID we are using proteins. In FRET, we can also attach chemical dyes plate compatible hemicell. So that attaching is little different. But when it comes to the protein attaching, it has to be an active fusion protein by using using the linker sequence. The most optimized flexible linker that works is about 12 to 14 amino acid length, and it's the GC rich linker that is the flexi linker we call. So we have optimized these kind of things, and that is, we have a set construct where we just transfer the protein after protein and make new pairs. That is what we do. Yeah.
So I have one question.
Sure.
So regarding the Brate assays, I mean, is it quantitative or like, as opposed to if I want to find out how much protein has been phosphorylated versus your Brate assay, because you are monitoring some structural changes. So, you know, how much of the protein has been
Yes, so I got your question. I think the basic answer, in short answer, what I can tell you is the optical imaging. So the imaging itself is popular because it is gaining popular because it is not just the look. So the visual confirmation is supplemented by the quantitative element. So every image has its integrated quantitative value, and we can extract that from the image. And that is the value based on which we calculate the ratio, the accepted by donor ratio, and further its calculation, the spectral overlap and all that, there are correction factors. So all that thing comes into the calculation of Brate ratio. So the Brate ratio is, or Freight ratio, they are in no uncertain term. They are very specific and they rigidly tell you, looking at the ratio, you can say the interaction intensity or the conformation that they can form, how tight they are. Many Brate pairs do not return a signal for many interactions because it only works in a very tight interaction. It is 1 to 10 nanometer, where many proteins actually interact and reach a distance at 30, 40 nanometer. So those proteins, you won't get a Brate or Freight signal. But that doesn't mean that those proteins do not work. You just can't build an Brate sensor. You have to use other kind of sensors like protein complementation assay or other forms of assessment you have to try. That's all. Probably I answered you. Okay.
Yeah, Dr. De, very
Yes,
nice and exciting presentations. Just not a question, just since you mentioned it's an interacting session. STAT3, cancer, and immune escape. These are the three keywords. Actually, cancers escape surveillance, and that's why early detection is a target and challenge. So now our basic and classical understanding about STAT3, we know about STAT molecules are the signaling molecules for all the cytokines, and STAT3 is the signature signaling molecule along with JAK-STAT pathway for IL-10 and IL-6.
Right.
And IL-10 is one of the target cytokine for majority of the cancer where we see immune suppression. And regarding the kinase, the counterpart or the downstream part is ERK. So if we correlate STAT3, IL-10 and ERK, the equation is more or less linear, although there are lots of. The next question is that if you are getting a protective things, there are many papers where you can look the another partner, a regulatory partner, that is STAT5. So STAT is one of the molecule within the STAT family.
Yep, of course. Yeah,
so STAT5 is more or less immunoprotective, where it gives IL-2 productions, whereas STAT3 is a kind of complicated molecules because it also gives IL-6, as you already mentioned. So these chains, I believe, need to be discovered in terms of.
You are absolutely right. It's a very, very complex area, but it is an hub. So that is where we first thought that let's try this.
But, I have seen that you have checked many cytokines excluding IL-10, which is one of the signature cytokines for IL-10.
I could not show all the data that I have.
IL-10 is one of the signature cytokine for STAT3.
Right.
Whatever the cytokines you have mentioned, they are very important, but they are associated with many other things. But classically, IL-10 is the signature for STAT3. I was wondering about that. That's it. Thank you.
Yeah, thank you. Okay, thanks. And there may be many more questions. Because of time limitations, we have to skip, and I request others can ask or interact with Abhijit Day during the lunch time and tea time and other things. Okay.
Now I request the session chair to kindly present a memento to Professor Abhijit Dev.
Organizers, should we go for third speaker? Yes, we'll move to the third talk today. This is will be given by Dr. Soumyaditya Mullah from BRC. His research interests include design and developments of organic fluorophore molecules for chemical and biological applications. He has been awarded with the Young Associateships Award of Maharashtra Academy of Sciences, DE, and DE Young Scientist Award. He has been also awarded ANR Fellowship for Postdoctoral Research in France, Raman Serpak PhD Fellowship for France. May I request Dr. Mullah to deliver his talk.
Okay, good afternoon, everybody. It's a difficult time to give a lecture, so everybody is angry, me too also. So I'll try to finish as quickly as we can. So I am here to talk about our activities going on in the bioorganic division in BRC, with the main focus on functional organic materials in the cellular imaging and cancer biology. So while I'm talking about the functional organic materials, I'm talking about the tailor-made small molecule bearing with specific functional group intended to do some specific job. So before going to the discussion, I will give you an overview of our divisional structure and expertise available in our division. It's a quite unique in the DAE family because we coexist with organic chemists and biologists, which is not, as far as my knowledge, it is not available in any other DAE institute, maybe except the NISER. So both of this wing has their independent activities, and we have different expertise. In the organic chemistry department, is asymmetric synthesis, sugar chemistry, nanomaterial synthesis, heterocyclic chemistry, peptide chemistry, and natural product chemistry. And our biologists are mainly focused on the cancer biology and radiation biologies, with their focusing on DNA repairs, autophagy, replication, etc., etc. They are also doing antibacterial activities also and cardiovascular diseases. And as we coexist in the same division, we have a junctional field where both organic chemists and biologists work together to develop design and synthesis of different functional molecules for different biological applications. So I'll be more focusing on this aspect. So before going to that aspect, quickly I will give you a few of the important activities going on in our division. One of such activities is the development of a synthesis of radiopharmaceutical ligands, where we develop the synthetic procedure of the well-known ligands, and we regularly supply it to the breed for their further applications. And this reduces the financial burden to the patient in our country. In another such activities is the synthesis of the APIs, which is a part of our Atmanirbhar Bharat program started by our Prime Minister, where we have synthesized this OTBN, and this synthetic methodology had been already transferred to a private company for their further scale up. And another activities where we developed different synthetic strategies for the different laser dyes important for our departmental uses. So we synthesized this material, and this methodology had been transferred to a private company for their further scale up. And in continuation also, we have developed several other laser dyes useful for our in-house applications. So in our biology department, they are mainly focused on understanding of biological processes at cellular and molecular levels. So they have used these two different models, standard culture model and also as mouse model. So quickly, I will give you two examples where in one example, they have shown the role of autophagy in the chemoresistance. So they have shown that sometimes that thalazoparib, that the PARP inhibitor doesn't work well to kill the cancer cell. And they have shown that it enhances the autophagy, which is the main reason for that. And if you use the chloroquine with this thalazoparib, so it works well, and it may be very effective for the killing of the cancer cells. In another example, they have shown the role of Werner protein in the regioresistance. So they did all this in-depth mechanistic study in the knockout cell and wild-type cell using Werner knockout and wild-type cell. And all these mechanics studies, they have established that it is really important for the regioresistance. So this is a classic example where organic chemists and biologists work together, develop a ReQL5 inhibitor for the breast cancer cell, where an organic chemist synthesized almost 20 to 30 compounds by changing all these different groups to make it very specific for the ReQL protein. And all this investigation, their interactions with this protein, their molecular dynamic study has been done, and this compound has been shown very efficient for in inhibiting the ReQL file. And this has been shown by the cancer cell as well as the mouse model, that in the wild type cell it is working nicely, and in the knockout cell it is not working. So they have also suggested the mechanism where this compound is making complex with the RAD51 and ReQL5 to suppress the homologous recomposition repair. And this is another example where Nestle product chemist worked together with the biologist, and he extracted different ingredients, active ingredients from the different medicinal plants or their fruits or their leaves. So this is one example where the fruit of the rampo tree, this compound has been extracted, and which is very effective for killing in the cancer cell. Another example where the DHS is the main component of the yucca flower. It has been isolated from it, and it has been used against the neuroblastoma cancer cell. And this pyrocatechol compound, which is the main ingredient of our pan patta, which is very effective against the antibiotic activity, showing antibiotic activity, and as well as for their cancer killing activities. So in the next part, I will be mainly focusing on the organic fluorophore based compounds, which are being used for different applications. One of such applications already I have discussed about the laser dyes. Another application we used to use this organic electronics and the photovoltaics. And this also used for the chemical and biosensors for the cellular imaging purposes, as well as for the photodynamic therapy of cancer. So I'll be focusing on these two parts here. And for these purposes, we actually used several different kinds of fluorophores. But here I'll be mainly focusing on this dye, which is Bodify class of dyes, which are basically organoboron complexes. And this dye is highly fluorescent, highly photostable, and it has a high extinction coefficient. So it is very useful for different applications. So you can do the different chemistry with this dye to change their wavelength, to change their different analyte sensitivity. So I'll discuss one by one. So in the chemical and biological sensor part, we focus on different analyte, which gives you an idea about different cellular mechanism, or to identify different cells as well as different disease information. So one of such example where we have synthesized a dye which is very specific to the serum albumin protein, which gives off-on type sensing against the serum albumin, and it has been used for the quantification of the HSA in the urine samples. Also, you have used this kind of dyes for sensing of the protein aggregates. So these dyes are very effective to detect the fibril from the lysosome fibrils. And this is a classic example where another dye can sense the fibril also, as well as we can see the oligomerization, where this dye we didn't see any oligomerization sensing. So this can be very useful to detect the starting of the fibrillization. So all these kind of dyes may be very useful for the detection of the neurodegenerative diseases. So in the next analyte, we are focused to synthesize some dyes specific for the copper plus 2 ions. So several dyes we have synthesized, their sensitivity against the copper plus 2 ion has been detected. And one dye, this phenyl body complex, is very useful to detect the intercellular copper plus ion in the detection of the intercellular copper plus ion is very effective to detect that one. In the next example, we have developed fluorescent sensor for the detection of intercellular labile iron pool also. So this will be presented in the poster session. So you can get details about that. So I will skip this part. And the next analyte, you are very interested about the proton, sensing the proton, because this pH can give you an idea about different cellular pathways to detect different cellular organelles as well as the cellular cell types. So for the several years, we are trying to develop different pH responsive probe. Here is one example that this dye changes its color with the pH range 1.8 to 7.4. This is another example where it shows the off-on type pH sensor with different pHs.
I am forming and I have more curiosity about is the ER2 lipid, that pH change, the dye that can change that sense that pH can change the color. So how is your thought that how will that work for the monitoring hypoxic environment within a tumor? So tumor, there are high pH, low pH area based on the hypoxia. So it is sensing intracellular pH change. So can it also sense in a physiologic context or in a tissue scale? So that was the question.
Okay. So it is basically going to ER first. So in ER, it is a hydrophilic environment. So it is green. So when it is making lipid droplets, its environment has been changed for hydrophilic to hydrophobic. And this dye has shown its change in fluorescence in the change in the environment. So yes. So when it is going from the hydrophilic zone to hydrophobic zone, it is changing its color. So that's why it is giving the dual color when it is going to the lipid cells, lipid droplets.
Hi, Dr. Mullah. Very good talk. I have a question regarding your copper ion sensitive dyes. So does it can discriminate between CO2 and CO3 plus state of copper intracellularly?
Yeah, it can detect copper. It can distinguish copper 1 and copper 2.
So the state of fluorescence is different, or
yeah. Yes, it is copper 1. It is not specific. It is not showing any decrease in fluorescence. But it is copper 2. It is decrease in fluorescence.
And,
so you can only detect copper 2, not the copper 1.
Okay. And how long in cells we can detect with this system in terms of time?
How long, sorry?
How long, like 72 hours up to 24 hours when you give these dyes? How stable in terms of time? How much we can track the cells?
These dyes are stable. Okay, for several days. If you yeah, for the several days you can keep it inside
That's excellent.
the cell. Yes.
Thank you so much.
So how did you, what makes the first pH sensitive dye mitochondria specific?
Okay. Okay, so I understood your question, because whatever the references you will get, it is either all are cationic, triphenylphosphine, or either that indologium, pyridinium complexes, they are used for the mitochondria specific. But this is a rare example where we have shown that it is a neutral dye specific for the mitochondria. And what we suggest that this tridyl group is very specific for the mitochondria. If you use this dye without this tridyl group, it is not very specific to the mitochondria. When you are attaching this one, that is changing its potential of the dye, which is attractive to our mitochondrial potential. So that's what I can say. So this tridyl group is very specific for the mitochondria. So without attaching to the triphenylphosphine or pyridinium moiety also, it is straight away going to the mitochondria, not in any other subcellular organelles.
Okay. And in the next one, where you are talking about the ER detecting.
Yes.
Yeah. Okay. So the assumption would be that lipid droplets should be made in bulk. Otherwise, that color change will not happen. Or in another way, if there is a situation where that happens, this would be a very effective way of detection.
Yes, actually, initially we are not interested to see the deep lipid droplets. So after synthesizing this compound, we have seen that it can also useful for see the lipid droplet synthesis. Initially, our aim was to make it specific for the ear. So that's what we attached this group with this body P dye to make it ear specific. But when we did the experimentation, at that time we saw that it is showing this kind of dual imaging. So then we say we saw the mechanism, how it is changing its color and how it is becoming red. Then we saw that due to the lipid droplet synthesis, it is becoming the red. But it was initially it was not our target.
But in other membranes, it will not change color?
No. In other, if it will change if your environment changes from the hydrophobic to hydrophilic. That is, if you change the environment, it will change it. But the dye is going to inside the cell. So if you tell about the membranes, it is not sticking to the membrane. So you will not see the membrane with this dye.
If you don't have, okay, I have a quick question on that mitochondria specific. Since you mentioned on the potential, did you measure the potential of the dye?
No. We didn't measure the potential of the dye. I am getting these experimental evidences.
Okay.
In continuation with the discussion with Oishi and the earlier questions. So when you say that body P dye doesn't partition into the membranes, that because body P dyes do partition into membranes, right? Am I right about it? The body P dyes, any of those, if you take, those do partition into membranes. So in the ER, see when you're saying that because of the hydrophobicity change, because now the dye is partitioning into the membrane, the lipid droplets, then you should expect that for all the body P dyes. Is it? I'm wondering if it is because of some of the derivation what you did, and that derivation either getting lost in the when it is partitioning into the membrane.
No.
Could that be the reason?
If you use this parent dye, it doesn't show any change in color. If you change this environment,
that's what precisely my question is, because that does partition into the membranes, though.
Yes.
Right?
Yes.
So that is not showing any change in color.
No.
Right? Its fluorescence property is same.
Yes.
But redshift is happening when you have the derivatization.
Yes. Only this and derivatization, and if you attach in two position only.
So is it possible that some of the moieties that you have derived onto the second position, is it getting lost, or some other new structure is getting complicated?
It doesn't go out because this is a covalent linking. So what happening, if you see this bond is single bond, it can rotate freely. Okay, so initially in the hydrophilic environment, these two moiety are not really linked in the same plane. Okay, but as well as when you are going to the hydrophilic to hydrophobic zone, this bond is somewhat restricted, and these two moieties coming in the same plane, which is eventually make it the red shifting in the fluorescence.
That sounds like
yes.
Okay. Do you have any more questions?
Yes. If there are no more questions, we will thank again Dr. Mullah for his nice presentation. I thank all the three speakers for nice presentations in this first session of this HBNI team meeting on life science RRK.
Okay, so now I would like to request the session chair to kindly present a memento to Professor Soumyaditya Mullah. Now, I also request to Dr. Sunil Ghosh to please come onto the stage and present a memento to the session chair, Dr. P.D. Naik. Thank you, sir. So now I request to Dr. Majumdar, sir, to kindly come and announce the further proceedings.
That ends our session 1. Though it started late, and you know that the first day is always like this, any conference or symposium. And I thank all the speakers, excluding myself, and 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 the session chair, Professor P.D. Naik. Now we'll break for lunch, and then next session is a poster session, and the poster session will be at the basement of this convention center, and there will be tea there twice, I think, and it is integrated now, integrated poster session, tea integrated poster session, so you will not feel like going for a separate session for tea. And then there will be evening lecture from 6:15 onwards by Professor Beda. And now let us disperse for lunch, and that's all. Bye.
The lunch is arranged at the rooftop of this convention center. Everyone can proceed there.
The same place where you took tea.